Good morning and welcome to the City and County's GIS Day. I'm your host, Doug Genzer, TS GIS Manager. Bruce Reagan will be assisting with the moderated Q&A, and Ben Daniel is our producer. We have a great program for you today with real-world examples of how GIS works for the City and County of Denver. We'll have 12 presentations, and please ask your questions via the live event Q&A tab in Teams. We'll also be giving away 5 ArcGIS for personal use licenses after the presentations. We'll ask a question about the presentations, and they will be awarded to the first person to answer correctly. Our GIS Day kickoff presentation is titled 2023 City Priorities in GIS by Chief Information Officer David Edinger. Dave, take it away.
Thanks, Doug. Good morning, everybody. David Edinger. I'm the CIO of Technology Services. We've got about 325 dedicated employees here who are supporting technology around a. This is my 4th or 5th year kicking off GIS Day, and this year's agenda looks really exceptional. We've got people from around the city analysts, individual contributors from agencies, students from the community. Of course, our GIS team that includes Doug, Technology Services. So to kick things, you've heard the phrase, if you want my priorities, you should know. Something along those lines. So we just finished the 2023 budget process at the City and County of Denver, so we'll start there. Housing stability and homeless resolution, clearly in the papers all the time, affordability crisis. We've got $200 million to invest in 2023 to support affordable housing initiatives. From community and behavioral health perspective, not quite as much, $36.5 million in ARPA funds that are going to be dedicated to support expanded behavioral health services. Public safety, also on a lot of folks' radar, $8.4 million to 88 new officers and increase our effective strength, our authorized strength, from a little under 16 to about 1,640 officers. That's the first increase in time there. And then where we'll focus a lot of discussion, at least in these first few minutes, is on the recovery. And the 2023 City and County of Denver budget on core and the surrounding neighborhoods in a variety of ways, including modernizing the 16th Street Mall. It's about time. Funding to support businesses. There's a lot of work going on with facades for businesses and that kind of thing. Events and activities, and enhancements to policing and public health services. And to do this, to invest all that money, we need to understand these priorities. We need to understand them so we can track progress and so that we can pivot when and where necessary. Today, you'll hear from Blake, Lisa, Spencer, and Simonas on how GIS is supporting all of these areas. How do we track the intersection of resource allocation and the desired outputs and outcomes? One of the things I've noticed and the data I've been looking at lately is just how much of what I would think would be GIS is really not based anymore. We're using other ways around the spatiality of the. And how do we use GIS to pull together disparate data sets we may have never looked at before or thought to look at before, so that we can triangulate and really pull together multiple perspectives and vantage points on a particular problem. Don't expect you to read this eye chart, but the point here is that Denver did a great job responding to COVID, but now we're kind of past that initial response, and we need to tackle the challenges of recovering from. Downtown recovery topic is on a lot of people's minds. Everybody's talking about it and has a thought on it, and we really use some data-informed discussion when it comes to the downtown recovery. So what you're looking at is visuals from Denver's Recovery Index, putting together all of those indicators into a centralized dashboard. No one data point tells the entire picture. As I mentioned before, policymakers in the city are looking to understand this from every viable angle, and multiple agency and it's a multidiscipline effort to bring all that data together. Much of the data is inherently spatial in nature, as I mentioned, but it doesn't always need to be displayed in a map. The city's GIS data is utilized across graphs and charts and dozens of dashboards. We're using Power BI and story maps as to pull that together in a meaningful way for decision makers and policymakers. And the power is that allows us to focus on these indicators and metrics in specific areas of the city. So in this case, we're using the geography of downtown as the filter. And a variety. Sometimes it's maps, sometimes it's table. We can get this data quickly and easily into the hands of the people who need it. And what are we doing in this particular example? We're looking for correlations between the data. For example, a question that comes up all the time, does increasing the number of events like parades and those types of things downtown result in a decrease in crime? Is there a correlation between those? If so, when and where and how, so that we might make a difference in terms of reducing crime and more safe downtown. As more and more people downtown area has underutilized space, you probably see vibrant downtown is causing a lot of concern. Downtown Denver Partnership, private sector enterprises, the mayor's administration, and many others are thinking of a particular question. And I think the big question is, do we try to put the genie back in the bottle and go back to pre-2020 status quo, or do we imagine a new type of future for downtown? What if downtown is just another 78 or so? How can we use data to help inform what that future looks like if we want to go in that direction? And how can we use this space to address other city challenges like affordable housing, mentioned earlier, turning downtown corridor. Here's another way we look at that. Data we're tracking, and this is the first time I've seen it, RTD ridership and collecting other foot traffic to provide location insights and intelligence, and understanding how these travel patterns are changing or being impacted by the development of other land uses. So never look at RTD data, at least I had never seen it. How can that inform what's happening in town, where we need to make investments, where an entirely different approach is needed? And finally, as I mentioned before, the post-COVID recovery of the city, and in particular, involves a number of interwoven objectives. GIS our efforts in these areas. GIS unveils the relationships between the challenges ahead of us, and every year GIS becomes an even more powerful tool. So I hope you're excited for the agenda, and I'll turn it back.
Thank you, Dave. Our next presentation is titled The URB Equity Index, a tool to direct equitable climate action programs, by Berenice Garcia of Climate Action, Sustainability and Resiliency, and Rachel Galton of the Office of Social Equity and Innovation.
Thank you, and now I'm going to share my screen. Just a second. Okay, good morning. How are you? Please write from where you are listening to me today. This is Berenice Garcia from the Office of Climate Action, Sustainability and Resiliency. I am the bilingual Equitable Implementation Administrator. I have a long title for the Energized Denver Building Performance Ordinance. And today I had the pleasure with my colleague, fantastic colleague, Rachel, to introduce you our tool that we call the Under-Resourced Buildings Equity Index. And we're going to show you applications, how we can use this tool, EIS, to direct investments and to help people that need it the most. Just a recap, some of you probably have heard about our building performance ordinance, where all commercial and multifamily buildings, they need to reduce their energy consumption by 2030. And this ordinance applies to buildings larger than 25,000 square feet they had to reduce a specific at their facilities, but also were including smaller buildings from 5,000 to 25,000 square feet. They have prescriptive options. If you are more interested about the things buildings have to do, I'm going to put a link on the chat later on. And why this is important? This is important because 49% of our greenhouse emissions are from this sector. So we need to do action, but at the same time, we need to advance equity. Just a note, the buildings that are for schools or municipal buildings, they don't fall into this ordinance, so they will have another route within the state performance ordinance. And hopefully, if we do all of this, we will decrease 30% of our consumption by 2030. But as I mentioned to you, yes, we want to advance our climate action goals. We want to help the planet. But at the same time, we need to be very sure that we don't harm people along the way. And that's why I was hired to make sure that all our policies and measures and initiatives are equitable. That yes, we're going to help the planet, but at the same time, we're going to help people advance and be happy in their lives. And many of you have seen this graphic about target universalism and about equity. We need to adapt the system for those that haven't been able to participate in our programs and processes. We need to adapt the system to increase the participation, but we need to offer all the options because not everyone wants to eat apples, so maybe they want oranges. Just some important concepts. You are working with GIS tools, probably you are familiar with these definitions. I just want to remind you that in this ordinance, we want to prioritize frontline like people of color, people with disabilities, people with chronic respiratory diseases, the youth, immigrants, undocumented community members, and also people living in our next neighborhoods. That our economic development department, I see that they will have a presentation later, they work together to classify these neighborhoods. So we're prioritizing buildings within these areas. And also those human service providers, cares, churches, seniors, all that they do a lot of work for our community. So we want to make sure that we prioritize the where they are located. So the focus areas I have been working on in this ordinance is to identify who are these buildings, where they're located in Denver, and with the building owners, the building tenants, community leaders, to how they can ordinance, which services they will need. And after that, we can launch a program that is coming in January. When we use data or when we start doing research, in my experience, we have some notions like, low-income people, they pay a lot of energy bills, more than their monthly income goes to rent. And sometimes they don't pay for food or for medicine because they have to pay the rent. So we know all this data. But sometimes, for policymakers to get buy-in from leadership, we need to back metrics. That's why we're using the URB Equity Index. And for us, it has helped us to identify where are these buildings that build them in reducing their energy consumption, and also to engage the community. With whom shall we talk first? And also how we can avoid harm, because we need to humanize our data. When we're talking about all these metrics, we're talking about people, and we need to make sure that we don't advance gentrification, we don't advance displacement. We need to be very careful, and also to direct investment and programming, to send engineers to to areas where we need to assess and help property managers to make these changes. Then working with Rachel, and I'm so grateful to the of social equity to help me put together this equity index, because this tool not only includes environmental factors such as climate vulnerability, drought, how a city or how a neighborhood is exposed to fires, flood, and other air pollution. We're also looking at these social and economic factors like racial composition, jobs, displacement, food insecurity, all is, and Rachel will show you a demo where you will see all the factors that we use. And this is helping us to identify these buildings for this ordinance and also prioritize where we should invest and send engineers, as I mentioned, to use, send Excel to work with the property managers, and also to make sure that we are within those areas, we are prioritizing the areas that have been harmed by the system through the years. And who are these buildings? And I hear that there is a picture of building tenants from naturally occurring affordable housing at one of the meetings we did in Montbello. So here they tell us, the housing conditions and their energy burden they have suffered through the years and currently. And here you can see a multifamily building located in Westwood, where we're working with the property manager to do some efficiency upgrades. And before the index, when you talk to community leaders, you talk to the host, to Dido, to X, they tell us like some leads and some ideas at which buildings we need to look at. So initially we developed this metric, like, we need to look at buildings located in the next neighborhoods, buildings that are affordable housing, or they help frontline community members, buildings that are nonprofits, buildings that are important to the community. But this is just our general ideas. We need, with the social equity index, we were able to expand on these metrics. And now, yes, we look at buildings located in nest neighborhoods, make sure that that building located in Montbello or Sun Valley really need the help. So with the equity index, yes, we look at those buildings, but how the equity index is low priority, high priority, affordable housing, naturally occurring affordable housing. The index really help us to identify where these buildings are located. And just a sneak peek, those buildings, they are not located at nest neighborhoods. We're seeing other areas, and with this index, you're realizing that other neighborhoods are starting more need in Denver. And now I'm going to have, before going to have Rachel, I want to give you some of our results that we using the index. So we have identified 86 buildings that are under-resourced in nest neighborhoods, and the majority of them are affordable housing and are naturally occurring affordable housing. This means that they are not regulated, they don't receive any local or federal government to run their operation of their buildings, but they keep rents affordable. But however, in general, the housing conditions, the windows, the envelope, the installation is not that great. So we're going to work with those property owners to make sure they receive technical assistance first. And other neighborhoods that is important for you, my friends, to watch that are not NES are Windsor, 5 Points, Union Station, Lincoln Park, Virginia Vale, and Spear, and so on. So in these neighborhoods, we're seeing buildings from the naturally occurring affordable housing that they will need support through this ordinance. And based on the index, there are other areas like energy burden, air quality index, like lack of trees, so on, that Rachel will show you that we need to start thinking about. And also the index has helped us to identify to whom shall we talk first, like which neighborhood shall we, do the outreach. So we went to Montbello, Westwood, East Colfax. We also have listening sessions that were virtual with property managers from those priority neighborhoods that the index was helping us to identify. One-on-one conversation. We were to tabling events, the Dia del Niño in Montbello. We were to Chile. It's good to the Viaduct Festival in Sun Valley. I went Southeast Denver community meetings, is the area near to Aurora. So the index can really direct you where to go and do outreach. And also which languages shall we use to go to those countries. For example, in Montbello, it was important to create these Spanish-speaking flyers. In Westwood, we did them Vietnamese, and some areas in East Colfax, I know I have for my future events, I need to do it in Burmese. Index is directing many of the activities I do at my office. And now, yes, I'm going to give the floor to Rachel to show you a demo of the index, and then I will get back and show you some of the applications we're doing to direct investment. Thank you.
Everyone, I'm Rachel Galton, as Berenice mentioned, from the Mayor's Office of Social Equity and Innovation. And so I'm just going to quickly walk you through this index that we developed in partnership with Kaiser. So just clicking past the pop-up screen, which just gives you a little introduction and privacy notice for any buildings that would potentially like to be removed. So this is kind of the app interface that you first open when you enter the tool. And so there are little buttons at the bottom that can show you how to use the map, one that is about how the index was created. You can look through all of the available layers because we've included both the index as well as layers that made up the index of all of the variables that made up the index, as well as other reference layers like nest neighborhoods, historically redlined areas, and things of that nature. And then, of course, a legend. And so I'll walk through each of those, but just wanted to give you that overview. So the initial pop-up screen has the equity index and then all of the identified URBs, but that's not where we started with this project. We started with the list of all of the Denver buildings over 25,000 square feet, and those are mapped here. We also are beginning to work with the Denver buildings under 25,000 square feet, but those are subject to different requirements, so we're not prioritizing those for funding in the same way. So we have all the Denver buildings over 25,000 square feet. And Berenice mentioned that they were beginning to look at those buildings based on factors that we know are typically used to identify high priority for equity, such as nest neighborhoods, that layer is toggled on right now, and then a number of other factors, such as whether those buildings are affordable housing and like whether the census tract is below the median income. And so they began to look at those factors to start to identify URBs, but wanted to actually have an index to help prioritize. You know, we have thousands of buildings in this list. How can we know which ones we should be looking at more closely to see if they also might potentially be identified as an under-resourced building? And so this index was built from about 20-something layers. Many of those layers came from the CDPHE environmental tool. So that has several variables, as Berenice was mentioning, related to both climate and environment, but as well as social and demographic factors. And then Kaiser also identified additional variables that were important to them to include in the index. And so you can toggle on and off any of those specific layers. So for example, here's the one for extreme heat days as it's spread across the city. Here's one for diabetes prevalence. And so each of these we took into consideration to figure who might be more burdened both by the impacts of climate change and ordinances that would require, you know, greater costs of housing. And so this index was developed by combining those variables using a social equity analysis solution that our city was a pilot partner with Esri in helping develop that tool. And so it gives a score to each of the census tracts. These rank them from 1 to 143 because some of the data available was older than 2019. I didn't want to use the most updated census tracts and then have to aggregate data across multiple census tracts that have since been broken up smaller. So I used those older boundaries. So it will rank them, 1 being highest priority, highest ranking on the equity index, highest need for support, and then lower values, which are the lighter green colors you see here, an area of lower need. So for example, this census tract here that I just clicked on, which is near Swansea, has an equity rank score of 2, so one of the highest priorities on our list. And then you can see the results for each of the variables that go into the index on the tract as well, if you want to learn more about that. You can also see that by toggling on the individual layers, but we didn't want people to have to toggle on every layer to see that information. So by using this index initially, that allowed Berenice's team to look at additional buildings over 25,000 square feet that fall into those census tracts and identify buildings that might not have been on that initial list of nest neighborhoods, low income, because as you can imagine, there are buildings that are in areas that are identified as nest or low income that may be owned by a large corporation that wouldn't need that financial support. And of course, buildings that are in wealthier areas but would need that support. And so this helped them prioritize where to look for additional buildings. And this gave us a list of URBs. I'll open up the legends. You can see those are kind of organized by the different types of facilities. So, supporting housing, supporting small businesses. We just added schools this morning, so there will be an updated layer as we're continuing to identify potential URBs. And one thing to note is that, an index like this can point you to where to look, but that's why the outreach efforts that Berenice was doing was so important to actually verify whether these buildings are those that need support. And so this map identifies potential URBs, but buildings still need to go through a process with CASR to actually be accepted as a URB for support. And this tool can just allow you to look up information about those buildings, whether it's the list of full buildings or the URBs. You can open a pop-up that shows kind of where it's located, its building ID, property name, and then some of those factors I mentioned previously, like whether it's affordable housing, serving frontline communities, things of that nature. And so you can look at that pop-up for any building. And so for building owners that are partnering with CASR, they could look up their building by searching by address. So I always just use the example of 201 West Colfax, which is the web building that many of us city employees work in. So you can go down there and see the point for that building. Of course, the web building is not a URB, but if you were a URB, you would be able to identify your building in that area. Yeah, I think that's kind of all the time we have to get into the details of the tool, but yeah, please reach out to Berenice or I if you have any questions. I'm going to pass it back to Berenice just for some closing slides.
Thank you, Rachel. I just want to respect the time of my next colleague that will speak. So as you say, we're going to prioritize them, like to whom we should do a full on-site energy audit. So, and we're going to use some of the criteria from the index to do an internal scoring, because we want to provide, benefits to the people living in the building. And some of the example is a multifamily at one of the next neighborhood with 70% of the people are BIPOC. But as Rachel, maybe at the Baker neighborhood that maybe has a higher equity index, but there is a building such as the Atlantis apartments that they help people with disabilities. So we also want to support them. And another program that my colleague at CASR is using the indexes for the Healthy Homes programs. This program is going to do energy efficiency upgrades at multifamily up to 3 units and single home families. They will do repairs of envelope, windows, heat. They will install heat pumps, super efficient AC, and he wants to know, okay, which areas I should go first, to whom I should talk, and which neighborhoods I should prioritize. So he was able to pull up data from the index and do an analysis of, using the air quality data, the asthma data, and then correlated to the equity index and check whether or not it's a next neighborhood. Now he knows which neighborhoods he should prioritize and apply this program. And also, as I mentioned to you at the beginning, sending engineers. Here, for example, we are in a church with Pastor Ho providing facilitation in Spanish because the index and also talking to community members, he prefers Spanish. So we sent also engineers to the Little Gun in South Federal to do an electrification study. And it's just amazing how the data and the outreach with the community can really help us direct all this investment and direct all of our programming, and also other leads that are social and economic components, the mental health. When you help these communities, to install new AC, the energy burden will decrease. They will pay less in utility bills, so the mental health will improve. And also workforce. We are trying to work with BIPOC contractors and the youth to empower them to go to this green tech. And when we send engineers to these areas, the mothers, the fathers get inspired and they say, I will love my kids, or even the kids tell us, I want to be an engineer in the future. So all these collateral benefits is by working and prioritizing the community. So next step a launch in January, so stay tuned for all our press release and communications about it. We're going to have it in Spanish for the time being, hopefully in Vietnamese if we see a need. And also we're going to do outreach about a new code to priority buildings because they need to learn about it. Also do annual updates and keep the momentum. As we want to collaborate, I don't want this tool to be only CASAR. I want this tool to be citywide. Feel free to use it. I'm going to put my email on the chat and just some takeaways. Humanize your data. These tools is holistic, help us to identify priority neighborhoods, do the outreach, buying for funding, and those indirect benefits I mentioned to you, that mental health, workforce, and so on. So I always finish like saying that we as an institutions have the responsibility to change the world, but we need people to do it. So thank you very much. And thank you to Rachel, Maria, Corey, host, Tito, community leaders, and my CASAR team. Thank you.
Thank you. Do we have any questions for Berenice or Rachel? If so, please type them in.
I don't see any so far, Doug.
Okay. So our next presentation is titled Denver Human Service Analytics, Driving Innovation Through Interagency Collaboration by Dr. Lisa Piscopo of Denver Human Services and Johnny Guretters from Technology Services, and Spencer Percival also from Technology Services.
Thank you. Thanks for the introduction, and thanks for inviting us to share our collaboration project between Denver Human Services and the GIS department. I'm going to provide an overview of the project and then pass it on to my colleagues who will go into more detail about the technology solution our two agencies implemented. Our neighborhood resource sites were stood up in part as a response to the COVID-19 pandemic. During the pandemic, access to our services at DHS were moved to online when our buildings were closed. Many of our clients without computers or internet access had a harder time applying for services that they needed. Transportation and the distance to and from our permanent locations was also a problem for some clients. We used a geographic analysis in the form of a neighborhood index to develop a place-based approach that has led us to explore new opportunities and target strategies to deliver services more effectively. Our Denver Human Service Index, which I'll just briefly go over in this tool, aggregates 16 key indicators by neighborhood into one summary map, which you see here. The darker shaded areas on the map illustrate areas where families are facing multiple obstacles and where societal and systemic challenges may limit opportunities across the Denver community. The darker shaded, the 16 key indicators covering the areas of health, education, economics, and community are represented in the index. You can click on any of them in the tool and see the values that make up each index score. The DHS index helps staff prioritize high-need neighborhoods where implementing additional access points for services may be most beneficial in enrolling people that are eligible for benefits but not enrolled. So next, I want to share with you the tool that the DHS staff uses to monitor our enrollment by neighborhood. We've chosen 4 locations to pilot 4 neighborhood resource sites in the areas identified by the geographic analysis. Here's the index again. The green stars represent our current permanent Denver Human Services buildings. And then we'll turn on our neighborhood resource sites. These orange stars represent our 4 neighborhood resource sites. This one is located in the St. Francis Center, and it primarily serves our unhoused population. This neighborhood resource site down here is housed in the Pena Health Clinic to allow more opportunity for folks in that neighborhood to access our resources. In Colorado, we have a state database called the Colorado Benefits Management System. These benefits include adult financial, medical assistance, SNAP, and TANF. We pull the data from the system and geocode it to the neighborhood level. Once geocoded and aggregated, the number of clients or cases can be monitored monthly. So I will here turn off our index and turn on the results of the aggregated CBMS data by neighborhood. You can click on any neighborhood and see change in enrollment by clients over time, month over month. By analyzing the data on a regular basis, we can assess impact, determine if these sites are helping clients access services, and provide necessary information to determine if more sites may be needed across Denver. However, the manual geocoding process was tedious and time-consuming. By myself, it took days to geocode, process, and update the mapping tool in ArcGIS Online. Our team in Denver Human Services provided me the data, I processed it, sent it back, they processed it, sent it back, and so on. To maintain the tool for the DHS team effectively, we needed to do this process each month. There had to be a better way. DHS collaborated with the GIS department to develop a better solution. Through this collaboration, we have a reliable tool, updated monthly, from which to monitor the impact these resource sites are providing. It greatly reduces my time it takes to maintain the tool. It reduces error and is timely and more reliable. In the end, this project and this collaboration process will benefit the community by enabling DHS staff to deliver services more effectively and efficiently. At this point, I'd like to introduce Johnny Gutierrez, a Denver Human Services IT data architect. Johnny, in partnership with Spencer, who will speak next, will explain how we collaborated to create a process to automate this work. Johnny?
Hi, so my name is Johnny Gutierrez. Like Lisa said, I'm the data architect for Denver Human Services and Tech Services with the city who worked on this. So I'm going to be talking a little bit about our collaboration with DHS leadership and the TS GIS team specifically, touching around ETL and SQL that we used to do this, CBMS. Addresses were a large component, how we built on the experience, and specifically working with Spencer Percival in our work together. Next slide, please. So working with DHS leadership, our project vision, like Lisa was talking about, included improving our service delivery, increasing access to services in our Denver communities, specifically seeing those trends of activity for the programs across Denver neighborhoods and across time. Across time is something that we, as the DHS technical experts, have not done as much kind of BI and analytics work before, so this was a good opportunity for us to kind of grow and provide more value in that aspect. So I received some technical vision as well from Aaron Gabler, our leader here at DHS Data and Technology. So he passed down his process for doing the monthly snapshots to store that data down, what Lisa was talking about, and provided some SQL code that he was using as well. And then we established some requirements, and these, just like most projects, save money and save time. So Esri, the geocoding process, like Lisa was talking about, was also expensive. We were using a lot of credits. This was costing us money every month, and it was taking up a lot of our time every month for Lisa and for my team as well. Next slide. So this is what the ETL landscape kind of looks like. So for those of you who aren't familiar or learning, ETL is extract, transform, and load, which is something that we did from first the data source, which is this extracts part right here. So from CBMS, we grabbed cases and programs for our clients along with their addresses. We used SQL to grab that. We had some conditions. We made sure that cases were active, programs were open, it's for Denver County, etc. Transformation. So we cleaned up the addresses and made them readable to the average person. And then we did some geocoding. So we appended the address data to get some more data points that were going to be valuable for us. And that's where Spencer really helped us out. And then loading. So we staged the data in some kind of Memory structures, we loaded them into separate tables. One is for specifically just the snapshots for that CBMS data. And then one was for the addresses. I have here highlighted SSOT. This is a single source of truth. This is also something new that we're doing here at DHS. And I'll talk about it more in a sec. So the people who were involved in this whole process were the TS, DBAs, the database administrators, the sysadmins, the GIS team, our data and tech team for DHS, and our leadership. Next slide. This is what the original flow looked like. So we were extracting out of the state system, that CBMS database, using SQL Developer, putting things into Excel, grabbing those addresses, doing the exchange with Lisa, time intensive, expensive, receiving from Lisa, putting that back into a SQL Server database that we used, and then again exporting some stuff out into Excel, passing that on to Lisa and helping her start the process of getting that into her tool. There were a lot of problems. It was very manual. The addresses could be extracted over and over again. Even if we had the same address, 123 A Street, we could hit that 123 A Street last month, this month, 3 months ago, and we'd pay for it every time, process it every time. So it was a little bit wasteful. That was also part of the high cost. And yeah, next slide. So real quick, before we move on to the future state, I wanted to talk a little bit more about that single source of truth thing. So it's the practice of structuring information models and associated data schemas such that every data element is mastered in one place. That's fancy speak for we can use this in a lot of ways. It allows us to use a concept like an address, store it down somewhere and say, this is what the address is, and we can use it in different places now. We're not mixing and matching. We're not getting confused anymore with how things are accessing that. It allows us to improve our reports, our applications, things like that. It also allows us to identify outliers, bad data, and we can communicate this with our users like our program managers. We call these exceptions, so we developed some exceptions reporting from this as well. Addresses was a perfect candidate for this kind of thing because the address, like I was saying earlier, can be used and reused many places in many ways. We're interested in this kind of information, and it's valuable to different folks. And the exceptions as well allow us to see anomalies and, hey, is something weird going on? Why are we having people enrolled in this program who live in this county, or why are these addresses so weird? Is there a pattern here? Is there something else we can look at? Next slide. And this is the new data flow. So we used SSIS, it's SQL Server Integration Services, an ETL tool to help us do this. You can see all the lines now say like automated because basically that's what we did. We automated everything. Now we use these staging tables in our SQL Server database environment. We extract only unique addresses. So if we have not encountered this address before, now that's what we're processing. Instead of the full list of like 300,000 or something that it was a month, now we're only doing like 1 to 5% of that. The blue parts here, what Spencer picks up, so in like step 3 and 4, he's doing some of his process there. So he'll talk about that. We pick that back up and then we split out the data into 2 different tables. One is that single source of truth table for addresses, and the other one is a snapshot table that gives us the month over month numbers for what's happening in that state benefit system, CBMS. So from the addresses table, we get those exceptions, but we bring those 2 tables back together, and that's what we then push back out to Spencer now, and he's taking care of more of the automation for Lisa there. So there's automation throughout. The address is a single source of truth, and that's allowing us to do a lot more with those addresses. There's less processing. It's much cheaper. Even sometimes, it's not costing us at all. It's lower maintenance. It's all maintained by itself. And we have the exceptions reporting from it. So I'll go ahead and pass on to Spencer.
All right. Thanks, Johnny. Thank you, Lisa. So as we've kind of now gotten that high-level overview of the data itself that Lisa's making use of, that manual workflow that she had to go through for such a long time, and Johnny's kind of touched on the back end of SSIS as well as SQL Server. I'm going to kind of jump in now to this updated geoprocessing workflow that we're doing on the GIS side. So Johnny's maintaining the data on his end, and we're now maintaining some of those same layers of our own in our enterprise geodatabase. So this task was really fun for me to work on, just because I got to use multiple applications across our platform, and so utilizing our ArcGIS Enterprise geodatabase, as well as Portal for ArcGIS, ArcGIS Online, Python, and then finally the API for Python, we're able to just fully automate this workflow for Lisa, so that even if she doesn't want to touch it anymore, she won't need to. But if she wants to, she can. So jumping just directly into the ArcPy workflow, just going to kind of go through how we have 2 tasks that we run. So Johnny talked about how he's providing those addresses that are not verified that we need to try and find. So we are geocoding those addresses, spatially joining them to the neighborhoods, and then I'm providing a flat file back to Johnny that has those addresses with the decimal degrees, the coordinates, and the associated neighborhoods tied to them. And then his program, his SSIS workflow, picks up that flat file, incorporates it into his monthly report tables, and then he spits out 2 new flat files for me to grab for my second task, which is the client totals by neighborhood, as well as the client totals by program type. So using Python, ArcPy, I break those that program table out by the 4 separate programs. So in total, I have 5 tables that I'm then updating 6 total feature classes with. And so each of those feature classes are now stored in our enterprise geodatabase, and each of them are updated with a new field for each month, joined to those associated summary tables, and then we're field calculating each of the new values for that month, and then as well as the change between the previous month and the new one. So we kind of get everything into enterprise, into SDE, and even though it's already been published, we've taken those services, those feature classes, and published them up as a map service into our portal server. So we now have an established map service that's pointing directly to our enterprise geodatabase. So as soon as I update those feature classes in our enterprise geodatabase, those new fields, that new data can be reflected immediately in the map service that's being fed into Lisa's web map. So the nice thing about that is that we can also maintain all of Lisa's symbology, her pop-ups, her line charts, without having to break anything. And you don't necessarily have to use Portal for this. You know, if you don't have access to Portal, you could use a hosted feature service for ArcGIS Online. Write a script to overwrite that service, because you're not altering the schema. You're simply adding a new field for each month. So you shouldn't be breaking any of those web maps if you're using the same schema anyways. But using Portal was just something we wanted to make use of. It was a good use case. So just wanted to dive right in and do it. So at this point, I could leave Lisa's web map alone. And we've updated that data. It's refreshed in her web map. We'll go ahead and bring up the web map itself. So what Lisa would technically have to do is go into her web map. So she has her Snap clients, and let's say we need to go in, we need to reconfigure our pop-ups. We might have, instead of October's data, we now have November's data. So we've got to go in and manually update the custom attribute display, point to the month of November if we want to do that. And then we also have line charts where we have to go in, scroll all the way to the bottom, add our new field for that new month. And so while this isn't that time consuming, it's not that taxing, what we can do is just take this one step further. We can go one step further so that if Lisa doesn't want to have to worry about doing this update on the web map each month, she can then focus on other tasks, other projects that she's working towards. We can then take this to that next step. Oops. And then, sorry, I got a little windows up. There we go. So then we can take that next step to make use of the ArcGIS API for Python. So what we can do is we can use the API to extract the item properties of Lisa's web map to a JSON file, save that directly to to its own JSON file, open it back up, or edit it in memory in that same instance, and be able to now start appending and updating a new JSON file that, as you see on the bottom right side, we can add that new field for that new month, and do that for each of the line charts, each of the pop-ups. If we wanted to update the symbology, we could, but we're mostly just focused on incorporating that latest month's data, saving that JSON file to a new sort of output from the original, And then we can use the API to then push all of that directly up to refresh the web map itself for Lisa, so that all of this data is being updated. Lisa doesn't have to worry about it, but at the same time, all of Lisa's end users have access to the latest and greatest information. So with that, I know I kind of flew through that, but always happy to kind of talk this through if anyone ever wants to reach out. But from here, I think we'll just kind of jump into some lessons learned, and I'll maybe throw it back to Johnny to kind of talk a little bit about, yeah, sort of our lessons learned and our kind of plan for the future.
Yeah, so for the lessons learned, we definitely gained for vision and technical capability between Spencer and I and Lisa and our teams, working together and synergizing, because none of us had really done this kind of thing before, and what we provided was more than I could have done alone, more than Spencer could have done alone, more than Lisa could have done alone. So it was great to work as a team and really be able to create the end product for Lisa and do it in a way that's really efficient for everybody and it's sustainable. It's something that we can build on, because now that we have, like, for us at DHS, for our data and tech team, that we've kind of proof of concept, did this single source of truth kind of idea, we're applying it in different places and we're growing with it, and it's going to allow us to do a lot of cool things and help our neighborhoods and our clients in new ways. So we're getting a lot out of it. Also, this exception stuff is really good. We're realizing, you know, our geocoding, it's only as accurate as the quality of the addresses. So if we can identify, hey, the quality is not right here, it's going to also improve the quality of our services as well, because we'll identify kind of the bad spots and continue to be more accurate over time. So yeah.
Yeah, I think and then kind of talking about moving forward, you know, Johnny and Lisa both kind of touched on it. We'd love to be able to identify new ways for us to work together and find new opportunities. So whether that's developing new techniques or new workflows, improving upon what we've already done, or identifying new projects that we can create something brand new, is something that I think we're definitely looking forward to going down the road. And so we kind of highlighted what our kind of end vision was at the end of this task. And, you know, for TSGIS, we're always focused on our department's strategic pillars, is what we call them. So, you know, kind of those hot button words like innovation, reliability, access. So we're providing access to our software for other departments, identifying new ways for them to use their data, display their data and visualize it. Reliability, making sure that this process that Johnny and I are making is running successfully on a monthly basis, so that, you know, Lisa doesn't have to get an email or an IM, you know, a week later saying, why hasn't the newest data come in? So making sure that process is working the way it needs to. And just kind of on that innovative side, you know, it's saving us time, it's making us more efficient and trying to identify more ways for us to do that. So I think with that, unless Lisa wanted to add anything else, I think that is the end of our presentation.
I think I'll add just one thing. I've been speaking about this project all over the country at human services conferences and research conferences. And people are watching, they're paying attention to this work. It's very innovative, especially applied to a new field like human services and service delivery. And so it's really exciting. And I thank the GIS team so much for their vision and help in this, because I think it really is contributing to better science in the GIS world and better service delivery moving forward. So thank you all.
Thank you. Bruce, looked like we got a few questions. Could you read them, please? Okay. Would you please explain a little more about SSOTS? For instance, once you have an address that is an SSOT point, how is this point recognized at the next data import?
So what we do is we sort of have some criteria that we use to match against the tools that Spencer has, and so we do that matching sometimes it's called an upsert. You can hear it commonly called in ETL world. So we do kind of an upsert. So we check to see if that criteria already exists for that address. And this is made up of like the address, street, the name, the direction of the street, the zip code, city, state, and I think that's it. So if those match, then we can ignore and not send that stuff out to Spencer. But if we don't have a match, then we know this is an address that we have not encountered before, which means that in our single source of truth kind of table, it's not there. So it's something that we should add. So we do that logic, we use that criteria. If we do match, we ignore it. If we don't match, we put it in, and then that's when it goes into the whole process of getting geocoded, coming back to us, and then going back out to Lisa.
Awesome. Hi, Spencer. Where's the script hosted that does the web map update you showed at the end? In a Jupyter notebook or just a Python script on your job server or somewhere else?
Sure. So this task, I did not use Jupyter Notebooks. It's all contained within a few Python scripts just because of the different tasks that take place between handing things off between Johnny and I. And that's stored on our job server and ran with our task scheduler that we use.
And then how long did this project take to get fully automated? Very exciting.
Well, Johnny's portion that he worked on was different from mine. This is something that Johnny and his team have been working on for quite a while, just to get it all set up. Getting a perfect list of addresses for all of your clients is not an easy thing to do. So in terms of the GIS effort, because we're getting a monthly update, it took in total probably just about a month of just getting the data, testing it, working on it as we can, and making sure it's working properly. Johnny, I don't know if you want to add anything to that.
Yeah, it was very iterative. We learned a lot as we went, just because it was our first time kind of proving out this sort of concept and doing this thing in real life. We found a lot of failure points. We had a lot of jobs failed. We scratched our heads a lot when things didn't match up or getting duplicates and things like that. So it was definitely a big learning process, and it took us, I think, months too, because also not all the issues were apparent. On the first go around, even when we thought we had it all figured out, we'd get some data that was bad or something would happen that was unexpected, and we learned a lot along the way for that, and all those things are really good because they're helping us now with the projects we're doing that are using a similar kind of architecture design, so we can anticipate some of those issues and design for them ahead of time.
I believe
Okay,
those
great
are all of
stuff.
our questions.
Great stuff, guys. Okay, our next presentation is titled Public Health Harms Hotspots by Blake Christensen of the Department of Safety and Spencer Percival of Technology Services.
There we go. Sorry, I wasn't taking me off mute. Thank you. I'm very, very excited to talk about some of the work that we've been doing in public safety, identifying hotspots of public health harms, and how we use GIS as both an analytical tool as well as a collaborative platform. So here's a quick outline of the presentation. First, I'm going to talk a little bit about the project on which the public health harms hotspots work was based on, place network investigations. Specifically, how are places impacted by behaviors and how do places impact behaviors? Then a little bit more about the collaboration, get specifically into the hotspots and how concentrated some of these harms are across the cities, as well as giving a little bit of a wrap up, as well as have some time for questions and comments. So just kind of a basic overview of what we call the crime triangle, or the problem or the harm triangle. And why places become important here. And so one of the conceptualizations of how crimes or how harms occur is offenders meet targets at specific times and places. And importantly, this gives us opportunities to intercede well before, just before, during, and after crimes occur to prevent those things from happening. And importantly, it brings this concept of place management into play. And so we can manipulate places to substantially reduce the likelihood of crimes, harms occurring in our communities. So we have historically focused primarily at crime sites or the sites where harms occur. But there, in this framework, are different places that can impact how crimes occur, how harms occur in our communities. And so we see 4 different types of places that we can interject in. Conversion settings, which are public places where likely offenders converge. We have comfort spaces, which are private and semi-private locations, often utilized by offenders or by people that are impacted by harms. And then we have these corrupting spots, which are legitimate places that often are used in various ways. And so what does that look like, practically speaking? You know, here's a quick schematic of what a persistently violent or persistent crime location might look like. So we have the crime site at an apartment building. We have a drug market outside of that apartment building. We have a couple conversion settings, a landmark and a corner store where we see people converge. We see this corrupting spot of a strip mall that might have, you know, a cell phone store or a fast food restaurant or some other purposes there. And then we see also some single family homes, you know, a handful of which are often are being used as these comfort spaces, these private spaces for nefarious purposes. Traditionally, what happens is that we spend a lot of time, effort, and energy addressing the crime site. And so we take out the crime site, crime goes away at that location for anywhere between like 1 and 3 months if we do the best practices at addressing the crime site. But after that 1 to 3 months, because we've left the rest of this network intact, we see crime come back at the levels it was previously. So, you know, we're not getting that sustained impact that we're seeking. We're not removing this crime place network and its ability to impact crimes and harms in this location. You know, instead, what we want to do is remove these opportunities and substantially interrupt this network of places. And so if we use this more robust methodology of addressing not just the crime sites but also these other types of locations, we often see far greater impacts in these locations at these specific hotspots. And as I mentioned, this is something that Denver has been doing under the Place Network Investigation umbrella for a bit. And so if we look at the impacts of this in real life, we see that, you know, we've been working one of these projects over on the west side of town in Westwood, near the intersection of Alameda and Federal Boulevard. Pre-project, we were seeing shootings every 45 days. After the implementation of this project, you know, we went 277 days, you know, followed by another period of time of 214 days. So we're looking at an average now of 171 days between shootings. You know, or a little bit differently, during this period of time, we should have expected somewhere between 8 and 9 shootings in this location. We've seen 2 shootings. So, you know, potentially we've prevented 7 incidents in this location. And there doesn't seem to be, you know, there's not that 1 to 3 month expiration date on some of the efforts that we're taking in this location, because we're substantially impacting these places beyond just enforcement. So then the question from the mayor's office after presenting a lot of these data was, okay, so we're impacting gun violence. Are there other types of harms that we can prevent using the same framework, the same methodology? So largely this is taken a public health approach to public safety. You know, I would be remiss if I didn't mention that we brought an analyst team from across city agencies. So not only Department of Safety and Technology Services, but we brought in DDPHE, Denver Human Services, Housing Stability, and OSCI to look at these data sets and come up with ways where we're not just impacting gun violence, but we're also looking at things like behavioral health measured through suicide, mental health, calls for service, and overdose, and traffic safety measured by serious bodily injury and fatal traffic accidents, domestic violence and family issues like runaways, child neglect and abuse. And then we also have included in here measurements of homeless encampments, not because we think they're harms, but because we think that those things substantially are influenced by these, the homelessness is exacerbating some of the other public health harms that we see in our community. So before I get to specifically what these hotspots look like, I want to kick it over to Spencer to talk a little bit about how we collaborated between all of these agencies using GIS as a platform.
Thanks, Blake. So, as you all just saw in Blake's previous slide, there could have been potentially a dozen or more data sets that would be going into trying to identify a final output that was required or being sought after by our city leadership. But that also came with, like you said, multiple analysts from across different agencies. So how could we create a collaborative environment for different analysts to work together and come together to kind of create that final sort of hotspot that we want to identify? But as you see here, there can be some historic barriers to collaborating with one another, and that can happen no matter where you work. So, I mean, you can experience data silos between teams and departments. That could be, it's just hard to get data from somebody, or maybe something's just sitting on their C drive and it's hard for us to get what we need. There is also sensitive data that needs to remain secure, especially when you're working in a department like Blake's in safety. You don't necessarily want sensitive data to be shared amongst the entire city employee, workforce. When you're collaborating with folks, you may end up with some stale or duplicate data, and that can be hard for everybody to determine, what's the latest output. I need the latest and greatest information. Like, where do we store that kind of authoritative data? And then, of course, having the proper platform available for us all to collaborate with, especially with spatial data. So I think you all know what I'm going to say, but how are we going to break those barriers down? We're going to create access for this team to ArcGIS Pro and ArcGIS Online. So by using ArcGIS Pro and ArcGIS Online, we're going to be able to secure sensitive data by creating a private group for us all to share content in ArcGIS Online that isn't visible to the rest of the organization in ArcGIS Online, and only those within that group can make use of that content, bring it down into their own ArcGIS Pro project, and be able to then work with that data themselves, do their own analysis, create their own outputs, and then they could then take their final outputs and pass it right back up to ArcGIS Online. And then kind of touched on this already, but we're creating a single point of access for data, spatial data, for our entire team. So Blake, if you just want to jump to the next slide, just a sort of straightforward workflow of just how we created this. It's, you have 5 different agencies that we set everybody up with ArcGIS Pro software, ArcGIS Online credentials, and then everybody could just kind of work locally on their analysis using Pro, store their working layers locally, and then perform any kind of geocoding, any additional work that they need to do. Take those final outputs, share it up to the group in ArcGIS Online, and then you kind of see that back and forth arrow between Pro and ArcGIS Online. We can then use our new layers, we can share them back up, the rest of the team can bring it back down, use it as they see fit, and then us on the GIS side of technology services, just providing technical support and training as needed for those who are not as familiar with ArcGIS software, and just making sure that everybody has the tools that they need to get the job done. And so then one of the greatest parts I think we all know about ArcGIS Online is us being able to create content, visual content with a final output for our end user. So our city leadership, we can use story maps, dashboards, web mapping applications to be able to show this final output, and then be able to now put that plan into action, identify those areas, and be able to visualize where those areas are. So with that, I'm going to hand things back over to Blake, and he's going to jump into the web mapping application that was built and go over that final output.
Yeah, thank you. Now to the more exciting stuff where we get to do some interactive demonstrations. So here is how we pulled all of these data sets together into one common platform. And so we had things like violent locations from police gun violence data. We had information about encampments through both the 911 system and the 311 system in brown here. serious bodily traffic accidents, represented now in red. A couple of different versions of domestic violence in blue. And so we can start to see that a lot of these locations begin overlapping, that different types of harms are impacting the same types of locations as we go to overdose calls for service and drug-related fatalities, mental health related issues like mental health calls for service and suicide fatalities from OME data. And so all of this then coalesces into 13 different locations that are impacted by a number of these different harms across the city here in purple. And so, the challenge is now, how do we impact these locations in meaningful and sustained ways? And so just a quick, a little bit more about the index that we developed to narrow down these locations into these specific hotspots. And so data sets were weighted according to proximity to untimely death. So the highest weight was given to things like overdose deaths, suicide deaths, and gun violence. So those identified locations got 5 points on the index. If it was a near miss, we called it 3 points. And so fatal and serious bodily traffic accidents and aggravated domestic violence, we called those near misses. And then things that we thought were precursors to these untimely deaths and other risk factors got a single point. And you can see the other harm types there that got this designation. And so, again, like we're using a hex as a place here, trying to keep it a small place. About an intersection area or a street block is effectively what each of these hexes were. So we're looking at 28,000 hexes with a max index range between 0 and 27 points. The highest index was 21 across the city. Some kind of notable outcomes looking at the summary of these hexes: 25,000, almost 26,000 of these places had a score of 0, i.e. they were not impacted by any of the, or they were not hotspots for any of these data sets. 113 of these had a score of greater than 11, so less than half of a percent were impacted by 3 or more of these harms. And just 835 had a max index score of about 5, of more than 5, meaning that they were leading towards untimely death. So these hotspots are very, very concentrated in the harms. And so that gives us an opportunity to impact, the hotspots account for 1.1 square miles. Excluding the airport, Denver's landmass is about 112, 113 square miles. And so they're less than a single % of our landmass, but they account for 8.5% of the suicides, 8% of drug fatalities, 10% of homicides, 13% of homicides and non-fatal shootings. Some of the things that we didn't even measure in this index were things like property crimes, but they're still impacting 5% of property crimes, and 4.5% of SBI traffic accidents are accountable to this just less than 1% of the city's landmass. And so there's an opportunity here to understand why the geographies of these locations are driving these patterns. So just a quick summary of kind of where we've been and where we're trying to go with these data. Phase 1 was answering the question, do these hotspots occur? Are all of these types of harms concentrated at specific locations? Resoundingly, I think we've answered that question is yes. That less than 1% of the city's landmass accounts for a disproportionate amount of suicide, overdoses, and drug fatality or gun fatalities. Phase 2, we've been working closely with Peak Academy to do an inventory of the city's programs that are meant to address these types of harms. And so we're finishing up that, and we're quickly moving into phase 3 on choosing sites, categorizing places according to the 4 C's of places, and taking action at those. And so they're no longer driving these types of behavior that, geography no longer predicts negative outcomes in our city. And with that, we can answer any questions if you have any comments in the chat, or please feel free to email me or Spencer if you have any questions about the presentation.
Can I read the questions now, Doug?
Yeah, great.
Okay, so number one, how does this idea to store and share information on ArcGIS Pro relate to the TS build-out of the data hub?
So you can think of that as sort of two different platforms, but there's no reason why the data that we're working on or build out with our final outputs, the attribute information that we generate from that couldn't be a part of the TS data hub. It depends on where that underlying data is stored. So we're sharing it amongst our GIS platform, but there's no reason why it could not also eventually be a part of the data hub.
Okay, so then there's kind of a three-part question here. Would like to hear more about the index, the weighting of variables, and what theory were they built on? Okay. And also, what is the statistical significance? The speaker mentioned that there was a reduction from 7 to 2 shootings, and how do you know that that wasn't just chance?
We have not done any specific statistical testing of these. One of the issues that we have is that there's only been 2 shootings, and so our post data are definitely impacted by small sample size. So we continue to work with as we get more and more time periods and more observations, communicating out kind of what we think, how strong our results are. I'm sorry, can you repeat the first question again?
Would like to hear more about the index, the weighting of variables. What theory was that based on?
Yeah, I mean, it was largely atheoretical, but we knew that we wanted to, one of the overarching principles of this project was reducing the impacts of untimely death. And so we wanted to make sure that those data sets, even though they're smaller, there's only a few hundred cases over a number of years in things like overdose deaths, drug fatalities, suicides, and homicides. And so we wanted to make sure that those data were overrepresented in the way we sampled things. But we know that our larger data sets, our near misses and our precursor data also provide kind of relevant context and nuance to these issues. So didn't want to completely lose those data sets as well. And so those are kind of the thoughts and the ideas of why a 0 to 5 point for each data set scale was used and how those things were combined.
And did you consider population density in this index?
No, we did not.
I believe those are all the questions we have, Doug.
Okay, great, thanks. So our next presentation is Denver's Park Equity Index by Joe Lovell of Denver Parks and Recreation.
Hi everyone, I'm Joe Lovell, GIS Data Administrator for Denver Parks and Recreation, and I'm going to talk to you guys a little bit today about our Neighborhood Equity Index. First off, what was the driver of change? Why did our department feel the need to start mapping equity and applying that to our programming? Well, first off, as you know, we're a growing city, and our department's responsible for maintaining and growing our parks and recreation system to keep up with that growth. Secondly, we recently completed a game plan for a healthy city, which is our department's long-range master plan. And this has guiding principles for diversity, equity, inclusion, as well as resiliency. And then finally, Denver citizens passed a dedicated sales tax for parks and recreation improvements that we're calling the Parks Legacy Fund. So this generates tens of millions of dollars that we previously didn't have in our budget. And so with that and a newly adopted master plan, we're striving to be more data-driven and equitable about spending those funds and fulfilling the goals of our master plan. So our equity index helps us identify historically underserved populations. It helps us evaluate the amount of park space and access to those park spaces for our citizens. It also helps us direct investment to the higher need neighborhoods to improve the quality of life for all Denver's residents. So jumping right in, our equity index is made up of 8 indicators. First, starting with these 5 socioeconomic indicators, which are generally the base for a lot of the other equity indexes in the city. So we're looking at higher concentrations of communities of color, youth populations, lower income populations, individuals with health disparities, and also overall population density. Most of this data was created or derived from the American Community Survey data, except for the health disparity indicator, which this year we were using childhood obesity that we got from the Colorado Department of Public Health and Environment. So these all serve as a great base map, like I said, for you'll see in a lot of other equity indexes, but specifically for parks, we incorporated 3 other indicators that were basically more internal analyses within our department. So we're looking at overall park access, which is a 10-minute walk or roll to a quality park. We're looking at park acreage, so the amount of actual parkland per 1,000 residents, which is sort of a national standard. And then also looking at our history of capital investments in our park system. So each of the indicators were assigned a 1 through 5 score based on natural breaks in each of the data sets. Those scores are then combined to create an overall index, and then the higher the score equals the higher the need. So I'm going to jump in and go through some of the individual indicator maps pretty quickly and lead us to our final overall neighborhood equity index. So starting with communities of color, you can see there's higher percentages in the West Denver as well as North Denver. And anybody familiar with Denver would be familiar with this map or have spent any time exploring any of our census data. And that'll go for most of these other indicators as well. So looking at youth population, you can see it's a little bit more well distributed across the city, although downtown stands out as an outlier where there's lower percentages of youth populations. Looking at low-income populations, we start to see some other trends with West Denver and North Denver standing out as areas of lower income, which would be traditionally underserved areas. Our childhood obesity similarly follows that trend, with West Denver and North Denver standing out as priority areas. And then population density is about what you would expect, with the urban core being much denser than some of the outlying areas of the city. For the park access, which is a 10-minute walk or roll to a park, we use the ArcGIS Online tools to do an analysis for quality parks. So for this analysis, we did not include fee-based parks such as golf courses. We didn't include parks that have yet to be developed. As well as some of the trail corridors that may lack some other park-like amenities beyond just a trail and a connection. So when looking at this, the gaps in service are highlighted in pink. We began to think, should we do this as a percentage of the neighborhood that has access, or should we take a deeper dive and really get into areas where residents actually live? A lot of the gaps in our park service are large bodies of water, golf courses, cemeteries, and industrial areas. So we wanted to sort of take a deeper dive and really focus on getting people access to parks and not really worried about some of those other land use areas that may lack park access. When it came to park acreage, we included everything that our department is responsible for. So this did include medians, fee-based areas like golf courses, undeveloped parks that will be developed in the future. And the reason for that is sort of every piece of parkland in some way or another does have a community benefit. So in doing our analysis with this, we decided to group the neighborhoods based on the Community Planning and Development's Neighborhood Planning Initiative units. So as you can see, the bold areas are groups of neighborhoods that have similar characteristics. And so when we were doing this analysis, we decided to follow suit and group all those neighborhoods together, count all the park acres in there, and divide that by the amount per 1,000 residents. So each neighborhood was then assigned the same score for those NPI areas. Similarly, for our capital investments, this is something that we track annually and have made a geospatial format to track where we've done projects throughout each given year. So this is a 10-year history that it'll be a rolling window as we update this in the future. But again, we group these to the neighborhood planning initiative areas, and again, just assign each of the neighborhoods the same score for that unit. So this is our overall index. The areas in darker green are areas that we've identified are areas of greater need that we should drive investment to and focus our work plans on. So you can see this is very similar to a lot of the other equity index maps from other agencies within the city. So how are we using the index? Well, primarily we're using it to prioritize our capital budget, to be more equity focused and data driven. We get requests for park improvements from all various sources, such as city council, city staff, registered neighborhood organizations, individual citizens, as well as other partner organizations. So when those come in, our first lens that we filter through is our equity index. And so we determined that we would prioritize project requests in higher need neighborhoods over ones in lesser need neighborhoods. In addition, we're taking an integrated approach to funding and completing our park projects. So areas that we can combine requests, such as replacing an old irrigation system and replacing sidewalks in a park that has aging sidewalks at the same time, would be a benefit. So that those kind of projects would get, where we can bundle them together, would get prioritized more. We also have additional data related to our asset conditions. So we would then vet those projects through our asset condition database and determine, if in fact those assets are in poor condition and need to be replaced, or are there other similar assets in other high need neighborhoods that are also in poor condition that we may want to prioritize over them. And then finally, looking at where we can partner with other city agencies and look for grant opportunities to, increase the impact of some of our projects. Similarly, with the equity index and its color coding with higher, we created a spreadsheet that allows us to sort each of the individual indicators. It's color coded to match the map just for sort of ease of use, but this allows us to target projects by specific indicator scores. So for example, our land acquisition program may want to sort our spreadsheets by the access and acreage. So neighborhoods that lack access or lack park acreage, we would direct our acquisition program funding towards those neighborhoods. Outdoor recreation programming, we may want to sort by youth or obesity and target our outreach for programming to those specific neighborhoods. Playground development obviously would be something more focused around youth. And so again, we can sort our spreadsheet and identify neighborhoods that have a higher youth population to create new innovative educational playground spaces that are also nature-based. And then finally, looking at our investment indicator, areas that we have not invested in the last 10 years may identify opportunities for funding deferred maintenance projects. So this is how we're using our index to help fulfill our master plan and be more equitable about spending our budget. So with that, I'll open it up to any questions, and I'll give you my contact information if anybody wants to reach out to me directly.
We currently don't have any questions, Joe.
Okay.
Okay, thank you, Joe. So our next presentation is titled Using GIS to Solve Complex Natural Resource Issues by Andy Perry of Denver Mountain Parks, Forestry and Natural Resources.
Good afternoon, everyone. Can you all see me? I was going to talk a little bit about using GIS to solve complex natural resources in our Denver mountain parks. And don't let the title fool you. I'm not solving all the complex natural resource issues out here, but we'll talk a little bit about our rudimentary GIS flow to to help solve these. And this is actually my first story map, so y'all go easy on me. But I'm not sure if everybody's familiar about our Denver Mountain Parks, but they were established over a century ago in 1912. You guys remember that number? It might come up later. And the Denver Mountain Parks consist of over 14,000 acres of parks and open space in 5 counties outside of Denver's municipal boundary. The mountain park system boasts a wide array of parks, historic structures, 2 bison herds, Red Rocks Amphitheater, Buffalo Bill's Grave and Museum, water resources, wildlife habitat, trails, and variety of recreational activities, ranging from the alpine environment of Mount Evans, which you can see off in the distance there, and to the plains and ecosystems of Daniels Park. This is one of our parks here, Echo Lake. So where are all the mountain parks? You can see here, I'm sorry my map's not a little bit bigger, but Denver's over here, up in the northeast corner of that, and then all the green, darker green polygons are Denver Mountain Parks, and these 2 offsets here. Daniels Park is down in Douglas County. One of our bison herds is down there. And then our newest park we just acquired from a donation is Axton Ranch up at along the northern boundary of Jefferson County and Gilpin counties. So what are some of the natural resource issues that we face up here? One of the big ones, which a lot of the stuff I'm going to talk about is connect to, is our water and watershed health. Denver's right here in the South Platte River Basin, which 28,000 square miles of this area drain into the Missouri River, including millions of acres of public lands, home to numerous threatened and endangered species. And the most important part, I guess, is this is the primary source of drinking water for the Front Range of Colorado, or 3/4 of all of Colorado's residents. So very important. And you guys are all familiar with some of the forest health and wildfire, mostly wildfire issues that we have in the Front Range and in some of our parks. These are some actual pictures I used without permission, but I'm still working on cleaning this up so we can post it. But this is actually Elephant Butte Park, one of our parks in the Evergreen area that we had a fire on 2 years ago. You can see some helicopters dropping water, very expensive stuff. This is actually a picture of the burnt and crispy forest afterwards. A couple other ones, and then here's kind of what a similar forest type looked unburned, but you can see how dense and unhealthy it is. There's bark beetle issues we have in there. You can see the fuel loadings in this one. I'm hovering over, and then this is some of the treated parks after we've gone in and done our work. And so what I'll talk a little bit more about here in a sec is kind of our workflow using GIS to get from this to this. So another one of our issues out here is noxious weeds. Noxious weeds are any non-native invasive plants that threaten and disrupt our natural agricultural lands. Their presence affects our waterways, wildlife, and recreation. They've been transferred here from all over the world, and they come here either from people, animals, nursery, and then they attach themselves in our soil and then take away the nutrients for our plants that we much more desire. So you can see some of the pictures here. Here's one of a orange hawkweed that's a list A species, which is very bad. You got to get rid of those. Also, wildlife issues, wildlife-human interactions. These are some pictures. Actually, I took this one of the elk here at one of our parks. This is a wildlife camera shot of one of the bears right here at our office in Morrison. They're another little bobcat from the same camera. So also we have to manage to make our wildlife happy and to reduce as much as we can the wildlife interactions, wildlife-human interactions. Now we'll get down to some of the nuts and bolts here. So people and the WUI, which is the wildland-urban interface. This is Evergreen, downtown Evergreen area. This is Dedese Park, Cub Creek Park, Bell Park, some of our other parks. I just want to show you a kind of a progression of layers I put on this map as to some of the issues with the amount of people and that surround our parks, which I know is an issue down in downtown, but up here in the hills it is as well. So there's just the beautiful park boundaries all by themselves. Boom. We put in the data for all the why am I brain farting? The polygons for houses, and then you go to the next one. These are all the structures that are there. So you can see some of the issues we may have with the parkland and the people surrounding those parklands. So what do we do? How are we using this? And these will be my focus parks right here. I'm sorry. Bell Park is kind of the one we just did a huge project in, so I'll show you what we did. So with Joe Lavelle's help, actually with Parks and Rec, he helped develop a 10-acre grid for us to overlay on our parks so that we could so have areas to go and measure what's going on within our parks. Each of these squares is a 10-acre grid, and then you see the stars in the middle. If I zoom back in, each star is the center point of that 10-acre plot, which we use as a measurement plot center to go and see what's going on in the woods. And then we'll get into using our survey 1, 2, 3 stuff, where we go, once we navigate to this spot, we go and we do tree measurements, take photos and all that kind of stuff, so we can get a better grip on what's going on with in those areas. There's somebody on my team measuring some trees. You can see some of the houses right next to our park there. Checking out some noxious weeds. And then survey 1, 2, 3, which I also will give Joe Lavelle some props for helping us develop this forest inventory survey guidebook. Actually, there's us not working in the woods right there. But here, so once we navigate to that point, we open up our survey 1, 2, 3, and automatically puts our lat long in there. And then we have the ability to fill in all of these blocks. Talking about, and we put the slope in there, the aspect, the elevation, our basal area factor, which is a measurement we look through a prism, and it helps us determine the density of trees in the area. Scrolling through some of this stuff, we measure the DBH of the tree, the diameter at the breast height, the height of the tree, canopy base, a bunch of other nerdy forestry tree stuff. And then we also have a compartment here for some plot photos. So what does all this information get us? We take all that information, put it into a comma separated value file, or anyway, we import it into a program called FVS, or Forest Vegetation Simulator. It's a program that the U.S. Forest Service put together, and you see this is some of the data that it helps us to get. We get the number average. It's an average per acre based on how many plots we have and how we measure. So we know the number of trees in that area, the basal area in there, all kinds of stuff, and we can take this and run virtual fires through the area. Just get a base value of the numbers that we want to be seeing, or what things that we should be worried about out in the woods there. So sorry about that. So how do we get to this area, which is a more healthy and sustainable forest structure for our Front Range, at least in some forest types? How do we get to that when we're starting with this? So we take all the information that I was kind of telling you. Here's Bell Park again. Can we even get in there and do something? So we take our slope maps and determine these are anywhere from 0 to 15%, 15 to 30%, and then the dark reds are actually that might be 45% and over, which is considered inoperable for a lot of the forestry stuff that we do. So can we even get in there and cut some trees and do better for the forest? I showed you all the map earlier, but do we have access into some of these areas? Is it feasible for us operationally to even take care of stuff in there? So once we know that, we go and we GPS our potential project boundaries. See these purple polygons here? That's where we end up doing some of our project, where it was feasible us to get in and do some treatments. Once we know that, we go in there and we mark trees so our contractors know what to cut, and determine any other operational requirements or limitations. And that's kind of the workflow to get into maybe one of our contractors coming in and using this cool little thing. This is a harvester forder machine cutting some trees at Bell Park. It digitally measures and trees and all this stuff. So that's about it.
Awesome. Thank you, Andy. Are there any questions for Andy?
There are none posted. I was curious, how many bison do we have?
That is a good question. I think because we've been donating to a lot of our Native American tribes here in the past couple of years, so we have, I think, a little bit less, but 20 plus females in each herd, I think, and then 1 to 2 bulls in each. And that's our 2 herds at Genesee and then at Daniels Park. So.
Okay, great. Thank you, Andy. Okay, our next presentation is titled Dottie Asset Inventory, How GIS is Integral to Asset Management by Jason Smiley of the Department of Transportation and Infrastructure. Jason?
Thanks, Doug. Hi, everyone. As Doug said, Jason Smiley, GIS Data Administrator with Dottie. So a lot of the work that I am focused on is our transportation and mobility planning efforts. And as we move into some of our asset management work, working in that realm to infuse GIS into some of those processes. So some of what I'll talk about today, really quick, we're in the middle of a citywide asset inventory project to collect some various asset data. So I'll go through the scope of that, the technology we're using, some of the data products, how that data is going to be used within Dottie, and then kind of a little quick background on where Dottie is around our asset management journey, why GIS is important in that aspect. So our basic scope, we wanted to use or deploy some specific technology to speed up this process and really try to expand our budgets as much as we could. So we pushed for a mobile data collection using 3D 360-degree imagery that's geo-referenced, mapping grade quality. And then part of this process was getting pavement data, which we capture every 5 years to support our pavement management processes. And then our data extraction, our spatial data extraction. So the GIS layers that we're focused on in this effort are listed, and the imagery gives us a more ability or extra ability to go out and collect more data, either internally or using that same imagery with the same vendor or different vendor to collect additional features as needed, as well as all of the attribution that goes with this. So a lot of attributes we're collecting to really make this data useful. The technology, so our past processes, a lot of it has been manual, which results in spreadsheets. So we end up, we've used some less technical vendors in the past. We get highly formatted spreadsheets. That generates a lot of work on our end to get that formatted, to get it to a database format, get it into GIS, and anywhere else we need to get it into our enterprise asset management systems and others. And it's just not an efficient, cost-efficient process. We've moved into something similar to this, some mobile data collection. We use this internally a lot as well for smaller scale collection efforts, using field maps, other Survey123, other tools. We use Cartograph as one of our asset management systems. There is a mobile application that supports that tool as well. So we deploy these on iPads, some tablets, and iPhones a lot. The issue with both of these, we end up with this. A lot of people out walking around looking at mobile devices. We've relied on interns in the past or some local universities and schools to help us do data collection. And it comes back to it's just not efficient. So what we wanted to deploy for this effort was this van. Our vendor, who is Roadway Asset Services, they deploy multiple of these vans. It has pavement collection sensors. Those are the downward facing sensors on the front and back that collect high res imagery, and we can map all the pavement distresses off of those. And then the Ladybug roof mounted camera, it's a 30 megapixel camera. There's actually 4 or 5 cameras on there, so there is one pointing straight up. So it gives us a lot of flexibility. And having it really high roof mount on it tries to, in an effort to reduce the obscurities we get when driving the streets. So we deployed 2 vans in the city. It was 4 people total, 2 in each van. And the vendor was able to drive the entire city, every roadway, in just about 2 months. So it was really quick. We're in data processing and data extraction now. So real quick on the data products, this is just kind of a snapshot of what the pavement imagery looks like. Extremely high res, all those distresses and rutting and cracks you see in there, those actually get mapped through some machine learning. So we get GIS data for that, just stuff that we can use as reference as needed. Everything gets tied back to our street center line data using master ID as a primary key. So while a lot of this is tabular data, we can map this and visualize distresses, and then how we manage this data, visualize some of the worst parts of the city and where we need to focus some efforts. The imagery, so just a quick snapshot, you can see the detail in this. Everything that's visible within the right-of-way, we're working to map, so the quality of the signs, to get images from that, to map those, to get the details, the exact text on them, the bike lanes, vertical elements, all this stuff. So the imagery, again, and we can map anything that's visual or visible off this, so that is future effort, future work. So just a quick snapshot of what the data looks like. We're working through pilot data now, but we have linked images to all of the asset features, but you see the detail of how we can map this now. So being able to understand if it's a double yellow or a bike lane or what that sign is, and find images to put this in a digital representation and use this for really anything we need it for. So how we're going to use this initially, the pavement data we put into an asset management system. We recalculate our PCI, which is the pavement condition index, which is effectively the criticality of our pavement, the failure criticality. We use this to revise a 5-year plan. We use that plan then to develop annual plans in coordination with internal and external agencies. The inventory data, as we build up our asset management capabilities, we want to focus on condition assessments and, of course, inventory. Use that data to develop maintenance plans. And we haven't had a good inventory in the past, so maintenance planning has been a bit sporadic and not as accurate as we would like it to be. And real quick back to this, a lot of other uses for this data. These were just some quick examples, but kind of an idea of where we're going. So for the GIS data in the imagery, what we're going to focus on with the spatial data is using it to analyze our various systems. And when I say system, I'm talking about road networks, sign systems, striping and markings, all those things, all those assets, anything that DOTI is responsible for maintaining. So identifying, when we can visualize using the spatial data, what an intersection looks like, what the striping is there, and do scenario planning to look at safety improvements and safety planning and potential upgrades for things. And as technology changes, being able to identify assets where new technology options are available and we can replace those. Also project scoping. If we don't know what is in our right-of-way, what may get torn up as part of a project, it's hard to know without going out, mapping all this stuff, what needs to be replaced and then what the cost is of all that. So as we build up our asset management capabilities, we will have replacement costs, values of assets, and really be able to dial in our project scoping. For the 3D imagery, we're looking to deploy the Esri Oriented Imagery Catalog. It also has an add-in for ArcGIS Online and Pro, and then be able to share this imagery, which is, imagine Google Street View, share this imagery citywide so that any agency or department will have access to it. Without having to go out in the field, you can pull this imagery up, be able to do some quick measurements, just some situational awareness of what is out there and what you may be looking at, without having to put people in harm's way to go out in the field for quick measurements or something that they don't need to be out there for very long for. So our asset management journey, this is a lot, and it's a lot of text on here. I'm not going to read it all, but it's kind of about where have we been and where we're going. So without good inventory, without good spatial data and connected systems, we've struggled in the past to really coordinate maintenance efforts. So using the analogy of we pave a street and then tear it up to put in a new sewer line or something. So it helps with coordination. We've had inefficient data sharing, data collection processes, trying to coordinate that better to save money. Overall, we've been in a reactive approach. So this is waiting around for something to happen, for a failure, and then going to fix it. And that's tends to be a more expensive approach. Incomplete asset inventory. How do we know what we manage or maintain if we don't know where it is or what it is? And then we have various maturity levels of asset management efforts within the department. So we're trying to right size that. So we're adopting standards, international standards. We want to ultimately optimize our service delivery, go to more predictive approach and be more risk and value driven. And you can see on the right, it's a difference between what is managing an asset and what is asset management. And this is what we're trying to move from that left to that right side. And this will take time. It is an effort. It's a large department-wide coordinated effort, but it will pay off in the long run. So why is GIS important in asset management? We store all of our assets. Everything is spatial. So we store it in GIS. It is tightly integrated, our GIS database, tightly integrated with our various EAM systems, our enterprise asset management systems, which feeds out to anything we want to do within the department. So from operations, maintenance, planning, finance, budget planning, all these different areas, we feed that data out to, and it builds that single source of truth for us. What does this look like from a data management perspective? So as we start to move through this process, we need to define a lot of different things of how we're going to manage the data, how we're going to update that, who is responsible for certain pieces of data, of assets, what does our governance look like, how do we use that for reporting and analysis, and updating our database, our inventory is a huge piece. So through this, we'll define standards, we'll define our asset hierarchies. So to what level do we really need to capture, or what detail do we need to capture our asset data? What are those critical attributes? What must we have in order to develop our maintenance plans and properly manage this stuff? And then how does that configured within our various EAM systems? And then ultimately, we establish those processes, roles, and responsibilities. And as an example, you can see the process map. This isn't necessarily ours in the current state, bit of where we want to go, and it's just there to highlight kind of how complex this is going to be, how it's going to integrate with various systems. And again, roles and responsibilities is a big part of that. That is it for me. I know I flew through that a little bit, but happy to answer any questions. If not, we can move along.
Jason, if you don't mind, we have a question for the previous speaker, and then we have 3 questions for you. So if Andy's still on the line, there was a question about how do you handle, what precautions do you take before knocking trees down in relation to squirrels and other wildlife?
That's a wonderful question, actually. We go through, I know I ran through mine pretty quickly too. I was trying to give you guys a quick rundown on everything we have to do before trees are cut, but we do wildlife surveys. So we go through and do our best to check almost every tree in there to see for any kind of signs of wildlife. Squirrel homes, cavity nesting birds are a big one, and then any raptor nests, any other signs of wildlife, we are go through and take care of that prior to any trees coming down. So hopefully that helps to answer your question.
Nice. Thank you. Okay, if we can go back to Jason, here are some questions for you. One, do other city agencies have access to the ladybug images? Google Street View is very useful to the assessor's office for seeing building exteriors, and this sounds more recent and more thorough.
They will. We haven't received this as a product yet or a deliverable. We're in the middle of this collection now, and they are still post-processing the imagery. So once we get it, we're looking at probably early spring to get it a copy of the imagery. We're going to have to figure out how we store that internally, whether that's AWS or something else, and then how we share that. I've done some testing with the Esri-oriented imagery catalog. it works as advertised. So I think that is the goal. And then I'll be working with TS and Doug and his team to see how we get this shared out. If it's through ArcGIS Online, how we make that available as a service in a desktop software. And then if there's other options, we'll explore those. But the goal is to make this available to as many agencies as we can.
Okay, and then I guess the follow-up question is, do you have any idea of the timeline for that?
Yeah, the data, the imagery we could get sooner because they need the imagery in order to extract the data. The data we're looking at kind of middle end of Q2 2023 to have that as a final deliverable. The imagery will get somewhere around there too, and then it'll take us a little bit of time to get that shared out. So I'm hoping by next summer this will be available, but we will see.
Hey, thank you. I think that's all the questions we have for this presentation.
So Mike King was going to present on asset collection using field maps, but he is out sick today. So we'll skip to the next one, titled Geofence Technology Pilot, Using Field Maps to Assess Shared Micromobility GPS Accuracy in Lodo by Stephen Rojo and Jason Smiley of the Department of Transportation and Infrastructure.
Excellent. Let me get my screen shared here and we'll dive right in. So assuming that worked and folks can see my screen, my name's Stephen Rijo. I'm a principal city planner with Dottie working on our transit planning team. So I lead a lot of our transit planning efforts, bus corridors, rail corridors, but then also our shared micromobility and service programs fit under that, which is what here to talk about today. And just wanted to say off the top that having done my master's in geography and not really done as much technical GIS work of recent in my career, it's been really enjoyable to sit in, listen to all of this, doing a lot of really cool work at the city. So can let Jason introduce himself, but I guess he did just do that, so folks likely know him.
Yeah, again, Jason Smiley, Dottie GIS Data Administrator. So we'll let Stephen move on.
Awesome. So yeah, with that, we're here to talk about a geofence technology pilot that we did, and a lot of work Jason helped us pull together using field maps to assess some new kind of technology. So with that, I'll give a really quick overview of shared micromobility. That's the bike and scooter share program that many of you have likely ridden. We'll talk about the need for this pilot, our approach in designing it, and then spend most of the time talking about the results, some of our next steps and takeaways. But so with that, moving pretty quickly through the history of shared micromobility for folks who might not be as familiar, started with Denver B-Cycle back in 2010, first large-scale bike share system in the U.S. Unfortunately, they closed their doors in 2020. Around that time, dockless vehicles were showing up around the globe and then in the U.S. And so we started a pilot program in 2018 that ran for a few years as we just figured out how to best utilize this new technology. And then in May of 2021, we launched a license program with Lime and Lyft as our sole partners. And you can kind of see on the bottom there the fleet sizes they started with and how they've grown. That is for each operator who provides both bikes and scooters. Just showing the ridership, I like to contextualize our conversation here that in the red, you can see B-Cycle ridership over its timeline. And then in the last 4 years, you can see shared micromobility ridership. And so when folks are saying like, it feels like these vehicles all over and a lot of people are riding them, they really are. Denver's one of the higher ridership cities in the country and in the globe. And actually, there was a study of North America that when I did some back of napkin math, we are roughly 4% of shared micromobility trips and almost 6% of e-scooter trips across the continent are happening in Denver. So just exciting that people are using these vehicles. And then you can see some total numbers there. So B-Cycle 2.5 million trips over its 10 years, diverting about just under 1 million driving trips. In 4 years of shared micromobility, over 12 million trips that have diverted, as you can see, over 4 million driving trips. So trying to meet folks where they are, organize the system, and studies like these are a part of it. For this group, I wanted to highlight that we partner with a software company called Ride Report. They're an aggregator of transportation data really, but we use them for shared micromobility. They're how we manage the program, and are able to do a lot of the things that we will show you here. And while not the focus of this, wanted to share a few just interesting images and GIFs pulled from that I think the spatial folks on this call will find interesting. So this is Rocky's opening day this year in April of 22. Can see the vehicles kind of showing up and going away as there is the first pitch there. Another GIF, this is the Stanley Cup parade when the Avalanche won the Stanley Cup back in June. And you can see right around the parade start time, many of the vehicles in this core jumping down to the parade route. And I think just these remarkable things of how you really couldn't drive through downtown that day, but people are able to use, bikes and scooters to get all over. So the last plug I'll make is that while we have an internal dashboard with lots of insights that we're happy to partner with folks who are curious about, we did publish a public dashboard, which is the screenshot here that has a lot of the info that's publicly accessible, can download, interact with that. So just wanted to flag for this group, if anyone's interested, can click around that, see some heat maps, trends, and how we compare to other cities. So with that background on shared micromobility behind us, wanted to talk about the need for this pilot in Lodo. And again, just highlighting this rapidly evolving industry. We're figuring out, is it things like putting stickers on vehicles to get folks off the sidewalk, or putting stencils on the ground? If we want to organize parking, do we need to give people stations that feel somewhat similar to what we had with B-Cycle? And so over the last roughly 2 years since we've launched the license program, my team and I have been spending a lot of time working on all of these items. So just like to highlight the newness of this transportation mode we're planning for. And then dive into the topic at hand, which is geofences. Didn't want to belabor what is a geofence, as I think this group understands, but when you draw something on a map or in a mapping device that then creates a line of fence, a geofence, in reality that the technology interacts with. And so I wanted to highlight that Dottie uses geofences in a few specific applications. Where we'll get to with the study was we often get calls to use them in other places, but so there are some places around the city where we don't let folks ride. Maybe that's private property. The 16th Street Mall is a good example of that. We have some slow zones, some no parking zones, some preferred parking zones. We've done a lot of work with geofences around event management. So those bottom two photos is actually Ball Arena for one of those Stanley Cup final games where we had a no ride zone, a slow zone, and the preferred parking. You can then see the line of scooters at one of those preferred parking areas. A lot of partners with Parks and Trails, as there are some restrictions in how shared micromobility devices can interact with park facilities. And then we have things called opportunity areas, which provide both different pricing for different parts of the cities, in addition to deployment requirements, whereas a set number of vehicles need to be in certain neighborhoods every morning, for example. And so with those places where we think geofences work great, we keep getting requests, geofence this parking lot and geofence the street and geofence the sidewalk. Really highlighted a need for us to have a more formal policy around that. And so with that explosion of ridership that I showed on those initial slides, sidewalk riding was a challenge that we wanted to take a stab at and see if this is a good technology to limit that, or something we should be thinking of differently. And so with that, the approach to the pilot was really, again, how do we pilot geofence technology to limit sidewalk riding and also test GPS accuracy in Lodo? Because again, I think not lost on this group, GPS is a known technology that we understand pretty well where it works and where it doesn't, but understanding on some of these blocks in Lodo that sees some of the highest ridership in the city, how that geofence technology works. And so in designing the pilot, we picked a stretch of road that was a little lower risk for riders than some of the other streets, as we're testing this out in the real world in the built environment. Wanted to make sure we're not posing risks to riders just going through on their commutes. We then created a geofence and the collection app and field maps, and have some images of this on coming slides, but wanted to lay out all the design here. We then turned on a no ride zone on a sidewalk on the southeast side of Lawrence Street downtown. We did this between 15th and 17th, and we did it on a Monday, kind of during the daytime hours, which is typically the lowest ridership times. Mondays mornings, we see more ridership in the evenings and on the weekends. The city staff and operator staff then rode back and forth all day during that time, collecting data on where the geofence kicked in, when there were false positives, false negatives, and the like, and then used Esri field maps to document the observations. So you'll see that kind of screen capture on the right is an example of a very, simple form we used in field maps to capture, where do we drop the point, any notes, understanding the operator and the mode. These were the things that Jason was extremely helpful in pulling together. And we then collected roughly 850 points before we processed those. So I do want to pause here, see if there's anything you'd like to add here, Jason, since you were involved in the design.
No, the only thing I wanted to mention was that this was pulled together relatively fast because it was a request a bit higher up the org chart than we are. So those types of requests, we have to kind of scramble to get pulled together. So the data structure in this, I'll go through what we had to do, but we really kept it simple for the field purpose, and then had to break up those notes into various attributes. So I'll talk about that in a minute.
Yeah, no, I appreciate you pointing that out. I think it was less than a month from when we were, informed we should be performing a pilot like this to when we were performing it. And so, to Jason's point, ran quickly and went with the keep it simple approach. So wanted to give folks just a visual image of what we're talking about. Again, Lawrence Street downtown. It's a 6-lane road that has 2 lanes of parking, 3 lanes of traffic, 1 protected bike lane with some bus islands, buses operating. So we thought representative street downtown to test geofence technology on, but also representatively difficult. Has tall buildings, has the bridge over it, you can see. So, kind of that, if it can work here, it can work everywhere type of approach. We drew a no-ride geofence roughly mid-block to mid-block there, again, trying to not catch folks out in 15th or 17th. The mall was closed when we were doing this for construction, so we felt as safe of a test environment as we could create to try this in. And so hopefully this video will work, but again, giving folks a visual, we went out there, city staff, operator staff, rode back and forth all day from 8 to 4. And on the right, you'll actually see a screenshot. I used the Strava app to track. I myself went over 40 miles on this 2-block stretch over the course of the day. So significant amount of riding and data points that we'll get into in the analysis here. Couple images of the team out there testing bikes, testing scooters, both directions, riding in the sidewalk, riding in the bike lane, riding in the road, seeing how the geofence worked differently over the course of the day. So then that left us with, a bunch of points dropped on the map where the geofence kicked in that we were diving into analysis for. So with that, I'll kick it over to Jason to talk about how we set up those data attributes. How he set up those data attributes, I should say.
You're too modest. So as I mentioned, we really relied on a notes field for these guys to capture the critical information they wanted to. We teased this out, so we looked at mode, which was part of one of the standard drop-down options we had in the field app. But then we broke this out to look at travel direction, travel location. So were they on the sidewalk? Were they in a bike lane? Were they in the roadway? And because it is a one-way road, were they going with the flow of traffic or against an action? So did they stop or did they never stop? And if you see in the map that Stephen just showed, there's clusters of points at either end. Those are the people that the field guys just put out on either end as they did not stop, and then we understood which direction they were going. And then all the points in the middle that are near the geofence or just past are people that did stop. So we wanted to understand how far, so is it inside the geofence or was it parallel to the geofence? So were they on the sidewalk? That's a yes or no. Were they parallel to it in the road or in the bike lane? And then we put some measurements to it. So if they were beyond the geofence, how far before or after did it kick in? Or within the geofence, how far along did they get before it actually kicked in. So the full length of the geofence, I think, was 520 feet. So we'll see measurements, one never stopped, or then 0 to 50 broken up by 50-foot intervals, and then grouped accordingly, kind of group those points accordingly. So the attributes, you can skip to the next slide. And I'll let Stephen go through some of the results here and kind of the analysis breakdown.
Yeah, so this little tag team, definitely jump in, Jason. But I think, of the initial findings, as Jason started to take some of that data, process it, produce some charts and graphics, I think this was the most telling. In that, I have it on a future slide, but I'll say it now. I think it was Jason who said, it performed consistently inconsistent. And so we look here on the left, there were the times that it never stopped when someone was riding through the geofence. On the right, the action is when it did stop. And when you unpack it a little bit, you realize it's a bit concerning that the times it never stopped, you see that 306 on the sidewalk. Those are the times we did want the geofence to kick in, hoping for it to reduce the person's, propulsion and stop them there. Unfortunately, that was the least frequent time that it would, catch somebody. And then kind of jumping to the stop side of things, you see that it would stop the least on the sidewalk, then kind of representatively the next most in the bike lane, and then the most regularly in the roadway. And so really we zoomed out and said, even with this initial finding, first off, it's not working the way we intended. And then it actually almost has the opposite effect because it is least likely to catch a person on the sidewalk, which is where we want to slow them down, then a little more likely to catch them in the bike lane, which is where we don't want to slow them down, and the most likely to catch them out in the middle of the roadway, which is where we definitely don't want geofences kicking in. And so I think we took this and said, whoa, there's more to unpack there. And sort of on the next slide, you'll see tried to get at, is there a range? It's always about 50 feet accurate or 20 feet accurate or 300 feet to inform some of those geofence policies. But yeah, I think this is the one that jumped out at us and saying, if we were to geofence every single sidewalk and have this to be the way we reduce sidewalk riding, a savvy rider would know to actually ride on the sidewalks because that's when they're the least likely to get pinged. So some more findings, but I think this is a really telling one. And we'll pause briefly before going to the next slide, if there's anything to add.
Yeah, I was going to say, this gives you an idea of the effect of the tall buildings on a GPS receiver, that these things are bouncing around in there. In an urban corridor, and so when you're hugging a building, you're close to it, it's less likely to hit that receiver than it is if you're further away, so in the middle of the roadway or the bike lane. It's just more likely that receiver is going to get a ping.
Yeah, no, appreciate that. It's worth noting as we pulled this together, I remember saying, hey, Jason, we want to test this. And he's like, well, we know how it works, right? And so I think developing something to prove that out, but there were some nuances that I think were of interest. So again, with this one, it's the same colors as the last slide. You can see, the sidewalk where it should be kicking in, bike lane and roadway where it shouldn't. Even ignoring the travel lane people were in, you just see, the three largest buckets here are between 150 and 300 feet. So not a really accurate tool for, limiting riding on a 5-foot sidewalk. Better for some other applications. And I think, again, it was just seeing that variability is what highlighted, maybe this is a tool in the tool belt, but not the silver bullet. And moving along, unless there's anything to add, Jason, that last slide was when it kicked in within the geofence, to kind of Jason's point, talking about the data attributes. This shows when it kicked in outside of the geofence. And so kind of the fact that there are a lot of ones up there above the never stopped is a little concerning that it was kicking in, 400 feet past a 500-foot geofence. But then you look at that never stopped again, and it's those 306 sidewalk never stopped that are really the opposite outcome of what we're trying to get here. And so with that, I'll quickly run through some finding next step, and then eager to get into Q&A. That consistently inconsistent line that I forget who said it, was probably Jason, I think really highlighted, or rather was the main takeaway. As I mentioned, the no ride zones on sidewalks actually produced the opposite outcome and created some real concerns for us as, you know, when someone's getting caught out in the middle of the road, is that with live traffic, is there a car behind them? Some concerning moments there that definitely will inform how we continue to use geofences and have actually pulled some back since performing this. Again, you know, it often stopped in that 150 to 300 range, but at best was 25 feet, as that's kind of cell phone and vehicle accuracy. We found that speed really influenced. So if somebody was coming in at full speed or half speed, or if they stopped, you know, at one of the red lights along the corridor, the geofence would almost catch up to folks as the accuracy improved. But then also the things that influence GPS accuracy of, you know, time of day, maybe the battery level, the vehicle type, and the operator too. So much more to dive into there. Riders were often surprised by these sudden stops if they were unaware of why their vehicle stopped. You know, you saw the people, is this broken? Something like that. And sort of that closing line of, as I've mentioned, geofences are this really great tool for educating folks. Like, hey, this is a place you can't ride, or you get pinged when you're in a certain area, or, you know, parking or around really large events. But to use geofences as, again, the silver bullet for sidewalk riding is just not appropriate, and rather needs to be paired with other initiatives. And so with all that requiring further study, kind of the 4 next steps that my team and I are diving into is we're working with a consultant to take the analysis that Jason has performed, take it a step further, you know, repackage it, have something that can be our public facing policy there, and update that on the website and how we manage the program. And then it sort of gets to this point that I harp on. A lot of folks have heard me talk before, that, you know, there's infrastructure followed by education, followed by enforcement, then we innovate and we repeat. And so I think getting to, we got to build the infrastructure. It's the bike lanes for people to ride in, nice sidewalks for people to walk on, educate them that they're supposed to be riding bikes and scooters in the bike lane and not on the sidewalk, and then enforce that once we have a better network around the system. And so with that, partnering with Denver Moves Everyone, as they have a lot of recommendations for bike lanes downtown. So no, that was a lot of info pretty quickly. Happy to answer any questions or hand it off to the next presentation.
We do have one question. I wonder if you have demographic data for the bike and scooter report.
Yeah, so not as a part of this effort, given the need to really understand how it was operating in the lanes, in the street. We didn't decide to collect that subjective, you know, demographic data and observations, but we do partner with the operators to perform annual surveys that, you know, really get into this, and would be happy to share some of that later. Painting with a broad brush, we have found that shared micromobility ridership is generally more diverse than Denver's population as a whole, and that's across all indicators, be it race, age, socioeconomic status. So I think just highlighting that maybe more people than the general, you know, average makeup of Denver are using these new forms of transportation, and so that there really is an equity component to improving the system, improving safety, all those sorts of things. So great question. Would be happy to follow up with somebody if they're curious.
Thank you. That's all the questions we have. Oh, wait. Have you considered doing a pilot for using geo fences on other sidewalks where there aren't tall buildings around?
Yeah, great question. And I think it was Jason who suggested that's really the next thing we should jump into. So the budget available for this consultant study was really, how do we package what we found from the current pilot? But I think that would be the next thing we look into. Is there a place with more mid-rise buildings? Can we test it out in a park that has, you know, full daylight to the sky? I think it'd be interesting to understand how well it works where, since this represents more of a worst case, can we find that best case? So great question.
And I was going to add to that. I mean, the request was to focus on downtown because that is the most crowded area where we see a lot of riders. So yes, we could test this in more residential areas, but you just don't get the concentration of riders as you do downtown.
Really good point. Serving the highest and best need there.
Okay, thanks. So we are going to run a little late. We have 4 more presentations, but right now I'd like to introduce Phoebe Fuchs, and her presentation is titled Denver Moves Transit Phase 2, using GIS to prioritize bus stop improvement and bus priority treatments. Phoebe?
Sorry, just trying to find the unmute button there. Can everyone hear me and see my screen?
Yep.
Cool. Okay, I'll really try to make this a true lightning talk, knowing that we're running a little over time. So my name is Phoebe Fuchs. I'm also on the Dottie Transit team. I'm a planner, and I'm going to talk today about how we use GIS to stand up the programs as part of Denver Moves Transit. All right, so in 2019, we finished Denver Moves Transit, which was the city's first comprehensive transit plan. And essentially what that plan produced was this map of a network of transit capital investment corridors for future investments in service frequency, bus stop and station enhancements, and then speed and reliability treatments to help the buses run better on these streets. So since the completion of Denver Moves Transit, the team has been working on what we're calling Denver Moves Transit Phase 2, the goal of which has been to develop sub-programs to strategically implement this network. So today I'm going to talk about the bus priority program development, which involved a GIS analysis of about 350 miles of bus routes and nearly 3,000 bus stops. So the purpose of the bus priority program is to identify, evaluate, and prioritize near-term quick-built projects to improve bus operations on our streets. This used to be called the Speed and Reliability Program, so if you've heard of that, just know that it's the same thing. And here's an example of what a bus priority treatment looks like. This is a bus priority signal called a queue jump, which you can see right here, if you can see my cursor, allowing the bus to advance before general traffic. In this case, it allows the bus to merge all the way over to the left to make a left turn at Colfax, like just a block ahead. So it really helps the bus, and it's kind of a small quick build treatment that it's easily implementable. And also, bus priority not only makes transit faster for the passenger experience, but it allows RTD to operate their network more efficiently, requiring fewer overall buses and operators, which is extremely important given the nationwide bus driver shortage that we're experiencing right now. So to set up this program, we undertook a 4-step process. We analyzed a bunch of GIS data, identified problem areas where the buses get really stuck. We programmed theoretical treatments and then prioritized projects based on the cost benefit that we estimate from those treatments. So I'm going to walk through that today. The first thing we did was segment all of the existing bus routes serving Denver into more like stop-to-stop scale rather than like across a full route. So you can see that on this map. And then the data that we analyzed was just a massive amount of runboard data from RTD from both 2019 pre-pandemic and 2020. And our consultants built a existing conditions website to visualize all that data. So I'm going to show you that now. This is just an intro to the website defining all the different metrics we analyzed. And then we also talk about COVID a little bit. One thing we did do with the COVID data was identify what we're calling COVID essential routes. So those are routes that had relatively high ridership before the pandemic and did not experience big changes in ridership during the pandemic, which indicates that they serve transit essential essential workers who are transit dependent. So a great way to identify equity routes. And that's a list of those there. Okay, so in the interest of time, I'm going to skip over speed and talk about bus delay. So speed or delay rather, we define as basically the difference between the actual travel time of the bus and what the travel time would be in more free-flowing traffic conditions. So this map here is showing delay by segment. We've got both fall 2019 and 2020, like I mentioned, and then this map is showing both the AM and PM peak. We also have all-day data. And then another way that delay can somewhat be measured is with dwell, which is the amount of time that the bus spends at a stop actually serving passengers. So this map displays actually both dwell by graduated colors, as you can see here, and then the stop activity or ridership displayed in graduated symbols, which you can see here. And again, we have 2019, 2020, AM, PM peak, and all day. So we also measure ridership by looking at load, which is what this map shows. Load is the measure of the actual number of transit riders on the bus traveling on a segment at any given period of time. And load is really important because it tells us, we can use it to calculate passenger delay, which like load multiplied by delay tells you like the total amount of delay that's experienced by all the passengers at once. And so this was actually the primary metric that we use to identify problem segments for further analysis. And the last piece is reliability, measured through on-time performance and headway variability. I don't have any exciting maps here, so I'm going to jump back to my presentation. So for reliability, this chart right here is showing the least on-time routes from that fall 2019 period, with 30L on Federal Boulevard being the worst performing. So it's only on time about 41% of the time, which is way below the RTD goal of about 78%. So we used all of that analysis to hone in on 270 problem segments based on the criteria listed here. And this represents about 25% of the total transit network. So the next thing we did, our consultants built a GIS tool that we use to program treatments into projects, which we then use to estimate potential delay reductions based on those treatments. So this is like an example screenshot from the GIS tool, which shows a section of a project on Hampton Avenue and Havana Street, where some bus lanes, transit signal priority, and bus stop adjustments are recommended. So the output of the GIS tool is these delay reduction estimate charts. And so we can use those to play around with different alternatives. I'll flip back for a second. You can see in the screenshot here, there's like a no build alternative and then some other alternatives. We can use the outputs of those alternatives to understand like which assortment of like road width signal treatments would generate the best cost benefit for each project, and understand how helpful is it actually going to be for the bus versus how expensive is that treatment and how much of an impact is that going to have on the overall roadway network. So then finally, we use that cost benefit metric as well as other metrics such as the Dottie Equity Index to prioritize a list of projects to program and advance into design and implementation for like the next 5 to 10 years. Here's just a screenshot of what that spreadsheet looked like behind the scenes. We applied a little bit of an implementation lens to that and kind of built out this visionary 2030 program of projects that we'll work on over the next few years. And the next thing for us to do really is just a lot of coordination with CDOT, RTD, and other players. So yeah, the data-driven analysis has been really helpful, though. I'm happy I got to share it with you all. We definitely want to make that data useful as possible for all sorts of projects across Dottie and across the city, and want to continue to measure the delay and speed of our bus routes so we can understand the impact and success of our program. And that's all I have.
Thank you, Phoebe. Any questions for Phoebe?
We do not have any.
Okay, so our next presentation is titled Mapping Community Investment, DIDO and the American Rescue Plan Act by Simonas Sangaila. Simonas?
Sorry about that. Took me a minute to unmute. Can you all hear me?
Yes.
Awesome. Good to hear. All right. So my name is Berenice Garcia. I'm here on behalf of the DIDO Data and Technology team, and super excited to present one of our most recent GIS projects, which shows how our investments have been going out to the communities and neighborhoods around Denver. A little bit background about ARPA in general. So as some of you might be familiar, it is the American Rescue Plan Act, which allocated a little over $300 million to the Denver city and county in Denver and part of that has been allocated to our data budget, which has been used by our business development and neighborhood and equity stabilization teams to fund some of their programs. As these programs started rolling out, the data and technology team here saw an opportunity to create a tool that first would let us see internally how our programs are going, but also allow us to communicate this with our external stakeholders, whatever that be our elected officials or the public in general. So in order to do this, we went ahead and used a combination of the Esri ArcGIS suite as well as Microsoft Power BI on our data sources to create an informative and easy to interpret story map that we could share both with the public and internally. So just to give you a quick background of the process behind it, our data journey is relatively simple. Essentially what we're doing, we're collecting direct application data. So organizations, individuals are filling out form via our Engine portals. We use REST API to pull this data into our Power BI suite, where we process it and where we get the visuals you'll be seeing on our story map. They're directly connected to our data sources as well as geocode ready data. So the geocode ready data, also known as parsed, was mentioned before. It's essentially just address data that is ready to be geocoded without using any additional or expensive tools. Using this data, we run a short ArcPy model, which what essentially does assigns each of these addresses their respective council district and neighborhood. And using this assigned data, we are able to create our programmatic maps, as well as area-specific visuals. So you have multiple ways to kind of display where the money is going. So kind of now to have a little background of the process itself, let's go ahead and move over to the tool. So like I said, we wanted this tool to be accessible by the public, easy to find. We think, data is best when it's available, as most of you are familiar with. So if you go to our data website on the denvergov.org, look at our indicator and data program data. Among other things, you will see the city and county of Denver ARPA's performance. So moving over to that, we have our story map. So like I said, this is a tool that's present for both internal, external stakeholders. So we were really intentional at designing it to be easy to use, to be understandable, to be comprehensive, and also to be current. So it is important for us to have this, accessible to whoever comes. So in order to do that, we have, similar to how I talked about the background about ARPA, the Act in general, about what kind of programs we're running, the total impacts, and also each different program impacts. So as we move over through the descriptions of the Act, the programs, we move on to our first GIS feature, which is the comprehensive total award map. So this is essentially what it does. It takes data from the multiple programs that we're running through as data and combines them to see where the dollars are going. I think this is an extremely important tool to see that we are meeting the needs and meeting the goals that we're setting out. As you can see, the darker purple neighborhoods are the ones that are receiving the higher amount of funds. And if we look back at some of the equity indexes and the maps related to those that we looked at previously, we are matching the need with the funds. So I think that's super exciting. You're able to see this live. You're able to see not just what the city wants to do, but what the city is doing as well. We also have this divided up by our council district. So this is extremely important to our elected council members, for them to know how their communities are serving, how the programs are rolling out, and they can go in and see within their districts how many awardees are across programs are there and what is the dollar amount spent within their district. So As we move past this, we have dashboards that detail the demographics and detail the firmographics of where the money is going as well. I think this is important complement to the geographic visuals because it tells the full story of what DITO is doing. As we can see, just across our programs, we are really reaching out and going there to help our locally owned independent businesses. At 291, that is, close to 90% of all organizations awarded are these local businesses. I'm kind of talking about businesses. It's important moving into our Business Impact Opportunity Fund, which is designed to inject grants into these local businesses that have struggled during the COVID-19 pandemic and might need support via stabilization, loss of income, or just adjustment to the new period we're experiencing. So we see, once again, a standardized process where we kind of talk about the program, show the impacts in dollars, show the impacts in awards. We see that, show the firmographics. We see that accommodation, food services, which is, the industry that's probably hit the most during the COVID-19 pandemic, received around close to 30% of these awards. And as we keep exploring this tool, we can take a look at the distribution. So the Business Impact Opportunity Fund is probably our most widespread program. We're reaching as many businesses as we can within the city, and this is really displayed by our map. We see that the colors are much more varied. The distribution is much more varied, but we also still are touching the areas that we really wanted to be focused on. Once again, we have this as showing this by the dollar amounts, showing this by the award amounts, really going in there to make sure that this data can be easy to understand, showing it via graph, and obviously through our council district maps as well. So moving over to our neighbor activation grants, these are a little different. This is a program developed by our NEST team, the Neighborhood Equity and Civilization. And really what we're looking here is to revitalize or fund projects or events that really improve a business corridor or cultural district and really allow for the specific neighborhoods to flourish in specific areas. So once again, talking about the program, really go in depth with the impacts. As you can see, this program is a lot more focused. We have only 22 versus the 315 assisted organizations, but when you look at the grant amount, these are much greater. While the Business Impact Opportunity Fund was either 7,500 or 15,000. We're looking at grants that are closer to $100,000 per event or project. So moving, once again, we're moving into our maps, and I think the insight here is that as NEST tries to focus their efforts and tries to focus their allocated dollars into specific areas of the city, we can really see this in the map. Comparing to our previous map, we see that specific neighborhoods were touched upon, and these neighborhoods have been identified by NEST that they could probably benefit from the investment. In general, we see that the dollar amounts are much greater. This is something to be excited about, to be able to see that we're not just identifying where this money should go, but we're actually sending it where we want to. Lastly, kind of moving into our Business Navigator program. So this is a little different than what was seen before. In this scenario, we're not actually providing direct dollar assistance or financial assistance to the businesses. We're really providing the resources for them to be successful. This is more informational, technical resources, and hence we're going to be measuring this a little differently. So once again, really showing who are we assisting. Well, secondly, who our partners are assisting as we're working through our local regional partners. And across the map, you see that we're no longer measuring the dollars spent, but what we're doing is measuring the hours of technical assistance. So this is ongoing program that is updated weekly. As the previous data journey kind of showed, where businesses are filling out application, filling out form that would asking for assistance. We are connecting them with the local nonprofits or the local organizations that can help them, and they're reporting back to us of how many hours they provided. So as you can see, this map has a lot more clustered areas of assistance, and that's largely because these regional organizations that are helping out are specializing in a specific area, and they're reaching out to their local communities. They're really bringing really helping at a smaller scale. Yeah, so that's kind of goes over what we have so far. Obviously, as ARPA funds are flowing in to the city, as we're looking to expand what UDO does, and as we're looking to continue some of these programs, we are going to be looking to add more of them. But I think it's a great framework to have that we can show to a variety of stakeholders what UDO has been doing, where these funds have been going, and having a process that's standardized, that's streamlined, it's going to be extremely helpful to ensure that this data is current, up to date, and relevant. And that's it, what I have for now. So thank you so much for having me, and I'm open to any questions.
Thank you, but we don't have any questions at this time.
Thank you, thank you.
Okay, so our next presentation is Do You Know What I Median? Recalculating medians for aggregated ACS data with Python by Grant Gartzka of Community Planning and Development. Grant?
All right. There we go. Get my screen going. All right, thanks everyone. I'm going to be talking about a method to aggregate data that we're using here at the Community Planning Department. Basically, we have an issue where we need to take some median value data and we need to aggregate it up to our statistical neighborhoods. So I'm kind of going to talk about that and then get into some details. I'll try to go quickly, knowing this is a lightning talk and we're running a little bit over. So what do I median? A few things that I median are things like median household income, family income, median earnings, median age, all sorts of data like this. Most of the data we get is coming from American Community Survey data, ACS data, and you can probably get some of this down at like the block group level. We generally use it at the census tract level for most of our analysis here. We do a lot of work here across the whole city, not just this department, to make sure that our statistical neighborhoods are in line with our census tracts, because this allows us to aggregate that data up. Why do we want to do this? For a lot of our stakeholders, being able to see data at the neighborhood level is kind of the scale of geography and analysis that they best understand. So we want to cater to those needs, and even the general public, when we display data out that way, aren't probably interested in census tract 10, 1, 2, 2, 3, 4, 5, but they want to see what's happening in the highlands or something like that. So far we've kind of had a challenge with working with median data sets, because you can't really just take median data and average it together with the other census tracts that might exist in a neighborhood to get that score for the complete neighborhood. That wouldn't be statistically sound. I will say I think it has been done before, here at the city and elsewhere. I know we have done it, and sometimes we'll call it estimate data, but it's really not a statistically sound way of doing any sort of data analysis on median type of data. And then if you look at some of our data schemas that are out there on the Open Data Catalog or other tools we might have, you might notice that in our census tract data, we do display the median value for whatever variable we're looking at. But when we aggregate up and present to that neighborhood level, we often just drop it, because again, it's kind of like, well, we don't know what to do with it, and we know just averaging it is not correct. This year,
we had a program that was passed called Expanding Housing Affordability. Inside the rules of this kind of new policy, it says that we should be using Blueprint Denver's vulnerability to displacement score, which is a score that we process here at CPD. But we have traditionally always done that at, again, that census tract level. And this policy specifically calls out using it at the neighborhood scale. And as you can see, I put in here the 3 criteria for vulnerability to displacement. So we have % of renters, % of population with less than a bachelor's degree, and then medium household income. So now we have a problem because we have basically by legislation now have to present by neighborhood median household incomes. So what do we do? Well, I Googled it. I did a lot of research really to figure out what might be the best way to tackle this problem. There's a great document that is put out by the State of California Demography Office, and I can pop these links into the chat here in a second. But basically, it walks you through how you can recreate median values by basically going back to some of the raw data and recalculating median for your new kind of range of data as you pull data in. So just for example, I wanted to pull this over real fast. We can take a look at American Community Survey data, looking at household incomes. And you can see I have this by Denver census tract broken out. And you can see this B19001 table has median household income broken out into different ranges. And then we get a count by each census tract for how many households in that particular data value range, house income range follows there. So just for sake of exercise, this is showing you, looks like 3 census tracts right here. We'll take those. I don't know if they're in the same neighborhood or not. But let's say we want to try to aggregate this information. Since these are counts, we can add these together and we could get a number that then tells us what's the total count of these 3 census tracts that represents this particular income range. So that's kind of the basis of what we're trying to do here. And let me kind of quickly walk you through it as an example of kind of what this concept is here and what we're trying to produce. So here, this is basically the exact same table that I just showed you. It's formatted a little differently, but it's taken account of data broken up by those same income ranges. And the document says, here's what we need to do. First, we need to calculate a cumulative total of households, for our whole data set. So we're taking however many census tracts we need and counting all the households in there. So you can see, in this example, we now have a number. The next thing we need to do is calculate the midpoint of that number. So just take that number now and divide it by 2. And that tells us that, the median house is the 1,034th household in this whole data set. So then the next thing you need to do is figure out, well, where is this 1,034th household in the data range? Because that's our midpoint and that's what we're trying to identify. So that's going to fall in this data set, right? Kind of this range of data. So we can see we got our midpoint. We figure out what range that is in. The method actually says we're trying to identify the range just prior to where the midpoint falls. So that would be this range. And then this gives us our counting spot. So we're basically saying, well, from that range, the 988, that's where that one ends. And we need to count how many houses from 988 until we get to that 1,034. So we need 46 more households to get to our midpoint range from that known data value. So we know that it does fall in this data range. That's great. Basically what we're trying to do now is then figure out that proportion of how far we need to go before it was the count, but now we're trying to proportionally figure out into this range, how far do we go? Then we identify that our ranges are $5,000 ranges, mostly. They will vary across this, so you got to pay attention to that. But in this case, it's a $5,000 range. So we're basically applying that proportion to $5,000 to get our 2,212 data value. And then we need to add that to the range that our data value falls within to figure out the proportional, I guess, the depth or how far we're going into that data value to find the new median and where we land upon it. I hope I've lost you all now. It should be very confusing. I just kind of wanted to run you through that, but let's break it down. Just the highlights. Here's what we need to do. We need to get a count and a cumulative count of that total data range. We need to find the midpoint. We need to figure out proportionally kind of how far does it take to get into that midpoint. And then we need to apply that proportion to the data values to figure out what is the new number for our median household income, right? So all something we can do. That's a lot of pencil to paper to figure out. We have to do this now for 78 different statistical neighborhoods across the city of Denver. That's even more pencil pushing to figure all that out. A lot of numbers to process, a lot of different census data to pull out and pull through. So what do we do now? Well, let's take a look at how we can use the iterative powers of Python to quickly perform all this analysis for us. So let me get out of this presentation. And what I have here is a Jupyter notebook. What we have prepped, I did a little bit of cooking show prep here, where I took all that census tract data and I already counted it by neighborhood. But this is basically this, but replace census tracts with neighborhoods, and I did that count in that example I did at the beginning of the presentation. And you'll notice that the data, and when you get it, it's going this direction. Now I've shifted it so it's going across my spreadsheet here. And each one of these categories is the different income ranges. So this is the 0 to 10,000 right here, and so on forth. So I have this broken out by neighborhood. That's the cooking show prep of this table, but it was basically just another Python script to count all that data by neighborhood, because we can count those raw numbers. We can't average medians is the point. So if I go to my Jupyter notebook, I'm just doing a few simple things. The first thing I'm basically doing is reading that table I just showed you, and I'm passing it into a list for each one of those rows by using a data frame in the pandas module of Python. So we can run that real quickly. Should just take a second. And you can see what our result is a list of lists of each one of those rows in the table I showed you. So then the next step is that we actually have to do all that data processing. So let me just run this real fast to see we already have all our results right now by using the power of Python. But let me walk you through it real fast. What I'm trying to do is create a new a data schema. So I'm setting that up here. Here are my field names, and you can see, I'm looking for that total value. I'm looking for the midpoint, the matched value, that index, and that's setting up my value. Then I'm running through my master list here to say, for each list in that greater list, let's look at it and let's analyze all those numbers. So the first thing we need to do is pass our list into a NumPy array. If you take nothing else out of this presentation, just take this, and that is that if you're going to do any sort of math or calculation on a list in Python, you need to pass it to the array using this function. And then once we have all our data in that array, which is basically like a list but of numbers, we can say, okay, give me that cumulative list of numbers as we go along that line. Once we know what our total is from summing all of that data together, we can find the midpoint. And once we know the midpoint, we can then figure out, okay, where does that midpoint fall in that list? and then we can figure out the index of that, and I can show you all down here. Now here's our array. Here's our cumulative counting of this list. Now we can find our total. We can divide that by 2. We can figure out what value is our midpoint. We can figure out what is that index, basically a count of where does that fall in all these different values, to then say, well, give me one less than that to figure out what is that next number that falls before it that I can start counting from to figure out the proportion to find that middle point in our data. And we're just walking through that document, and then when we get to the end, we can find our new median household income broken out by each neighborhood. I'm also spitting all of this out into a table. I don't really need any of this information anymore, but I'm tracking it in this table. But you can see by neighborhood, we have our new recalculated median household incomes by neighborhood. I can take this and do a simple join to our neighborhood GIS file, and now we are able to solve that problem by how can we legislatively report out on what our median household incomes by neighborhood for that task. And that is my presentation.
Awesome, thank you, Grant. Does not appear that you have any questions at this time. We're going to power through. Our last presentation is called the Marijuana License Proximity Tool by Andrew Blunk of Technology Services. Andrew.
Hello, everyone. Thanks for sticking around. Last presentation of the day. I'm going to try to make it quick. So let me get this pulled up. So yeah, my name is Andrew Blunk. I'm with Technology Services, and I'm presenting on this marijuana proximity check tool that Excise and License just rolled out like last week or 2 weeks ago. This is pretty new and kind of cool. So a little background on this is Excise and License. They're the agency that issues licensing around marijuana businesses in the city. And there's a lot of regulations around where these businesses can reside, and so they get a lot of requests, about 30 to 50 a week of potential applicants calling in or sending emails saying, hey, is this potential location or this address, can we put a marijuana facility at this location? And so they have to go and do all these manual checks, and we'll go through some of what those are. But they were hoping to get a tool that would kind of make this process more efficient, help allow the public to do this process themselves rather than having to call in and have Excise and License do it. And then it also enhances their social equity program, where they're trying to help people that have been disenfranchised by previous marijuana laws to have access to these business licenses. And that just helps with overall transparency of how the city deals with this licensing. Okay, so the request was basically a web-based tool that could, a user could input an address into it, and then it would do some analysis around that address to tell the user whether or not they could put a different marijuana license there. And they had 4 different types of marijuana licenses that they wanted to be able to do. That have their own different types of restrictions. And so we'll kind of go over those. I'm going to use just one as an example, kind of coming up here. But, so it had to be publicly available. It had to be easy to use. It needed to be accurate. Even though, there's lots of disclaimers in this tool saying, these are preliminary findings. And you may have to go out and do additional research to determine if these locations are actually viable or not. And then, of course, the data has to be able to keep it up to date, and then to actually perform that function of determining if a location is eligible or ineligible for various licenses. Okay, so there's a lot of fine print around all of these restrictions, but kind of at a high level is, and this is specific to marijuana and retail marijuana or medical and retail marijuana stores, is they can't be within 1,000 feet of any school, child care facility, or any other marijuana facility, or a drug and alcohol treatments facility. You know, see, I kind of put in parentheses there. It's actually that 1,000 foot is measured to either from building to building or building to parcel boundary. And I'll kind of get into that because that gets a little tricky because a lot of this stuff we don't have data for. You know, we don't have child care facility parcels. That's not a data layer that we maintain in the city currently, or at the time we had. And then they also have to meet certain zoning and neighborhood regulations as well. So the idea of this tool is you're going to put in an address, and it's going to tell you does it meet all of these requirements. So the first part with any type of project like this is generating the data and getting it ready. And so the first kind of issue that I ran into was we don't have a lot of these. We don't have marijuana facility buildings or childcare parcels or drug and treatment facility buildings outlines, those building outlines. So I put together a model builder script that basically joins all this data together and outputs it, and then we publish it to ArcGIS server to then make it available in ArcGIS Online to build the application around this. I kind of circled this kind of up in the top right corner there that I'm actually, for this process, I'm using ArcGIS Pro and that task scheduler in there. It's actually Windows Task Scheduler. It kind of runs on the background, but this is runs nightly on our job server using this kind of built-in scheduling tool within ArcPro. It could also be exported out and run on our job server as well as just like through like Visual Cron or other scheduling tools, but kind of a newer use of this. We haven't used it a whole lot, and it's kind of a test run to see how it works. Okay, then after you have all the data prepared, you pull it into a web map. You want to symbolize it, create all your labeling, set the visibility lane or visibility range. And kind of why I'm pulling this up is I wanted to create some custom pop-ups in here. And what these custom pop-ups I wanted to be able to do was to display multiple features attributes within a single pop-up, which you see right here under that proximity information window. It's going to display when the user points and clicks on in the map, it will display the building ID, the neighborhood, and the zone district all in a single display rather than having to click through those pop-ups. So I thought this was kind of cool, something I found. Basically writing an arcade expression for each of the three features that you want to return, and setting those up in a custom attribute display. So I found this really useful. I didn't even realize this was possible until recently, so it was kind of cool that I thought I'd share. And the reason, and so there's another reason that I'm displaying. Okay, well, let me jump to this first. So the bulk of the application. So once you have your web app configured, you're pulling it into Web App Builder and building the app around it. And the primary tool in here is going to be the situational awareness tool. And this is a tool that allows a user to generate a buffer around a feature on the map and then return information that resides inside that buffer. So in our case, they wanted to know where are there any schools, school areas, child care facilities, all these other features within 1,000 feet. So you can configure this app to use 1,000 feet by default, so the user doesn't have to do too much on their end. But one kind of note here is when you try to use neighborhoods or zones in this tool, the buffer tool often select multiple zones or multiple neighborhoods, and it doesn't actually give you the closest or nearest one or the intersecting one. It just randomly gives you one of the 2 or 3 zones that intersects that buffer. So this tool actually didn't work for determining the zoning and neighborhood. So that was the reason that we put that into this pop-up here. And I'll do a demo of this. You'll see kind of how that works then. And we're going to do a live demo. So after that app was built, it's pulled into story maps. And it's kind of story map maps is kind of nice because we also embedded a bunch of instructions in here. So it's public facing, wanted to put in some really easy to follow instructions. You can kind of check those out. But it's really, we've continually refined this process to remove as many clicks and steps as possible. And we got it down to where it's really, what seemed like it was going to be really confusing. We were able to simplify this app quite a bit. With just a few clicks, the user will be able to determine if a address is eligible for a marijuana store. So what we essentially did was build 4 separate applications based on the different license type because they have different proximity restrictions for each one. So the user can go through here, read the instructions. We also embedded a video showing you as well. I'm going to do the marijuana store licenses. So what a user does is comes in and enters the address for where they would like to apply for a license. The application zooms to it. The user points and clicks on the building in which the license will reside. It returns their neighborhood and zone district for them. And they select this little ellipses and set location. And then that situational awareness tool, it runs its process. And so it will then tell you if any of these restricted facilities are within that 1,000-foot buffer. And so you can go and kind of click through these. So at 201 West Colfax, where many of us work, would not be eligible for a marijuana license, store license at this location because there are 2 childcare facilities within 1,000 feet. And there's also a marijuana store within 1,000 feet of that. So this location would be ineligible. And so I'm going to leave it at that. Feel free to check out that. I can drop the link in the chat maybe to this app, or you can find it on the website. But that's all I got.
Okay, any questions for Andrew?
I don't see any, Doug.
Okay, thanks, Andrew. Okay, so we're gonna, first of all, I'd like to thank everybody for hanging out and staying, although we went long. I'd also like to thank all our presenters, a lot of great presentations today. Now we're gonna give away our ArcGIS for public use licenses. So I'm gonna ask some questions. Bruce will paste them in the chat. And the first person to respond correctly in the chat will get a license. 1 per customer, please. So going back to Lisa Piscopo's, Dr. Lisa Piscopo's presentation, which 2 city agencies collaborated to enable better service delivery to Denver residents?
Is anyone even still on?
Still have 30 attendees.
Okay.
Okay, so let's try a different one. If anybody knows that one, they could respond. What year were our Denver mountain parks established? How many statistical neighborhoods are there in Denver? What does ACS stand for? And what does PCI stand for? So I don't see any answers. We'll give everybody 1 more minute. In case nobody answers, the first 5 people to send me an email will get the ArcGIS for public use license.
We do have some answers, Doug.
Oh, we do? Okay, cool.
All right, looks like Vanessa. Got the one for what year were our mountain parks established?
Okay.
And Anonymous picked up DHS and TS.
Nice. Okay, so if you did win, send me an email at douglas.genzer@denvergov.org. It's in the question and answers, and I will make sure you get a license. Okay, I think we're going to call it. Thank you, everybody, for your participation and for being here. Have a great day. Bye.